down here,
There we
we're
go.
down about 1200. We're at about 1200 feet, but then we've got it's a valley, so on both sides we've got peaks that are 700, 800 feet high, on both sides. So man, it makes a nice setup
Yeah,
for
there's
repeaters.
they help a lot. So other questions or thoughts? Don't be shy. This is a good time to do it.
Hey, I've got a question for you, Scott. Yesterday, you had mentioned slow scan TV and where those frequencies should set and where there's a lot of room.
Hmm.
But when I
Well,
was
no,
looking at,
that's fast scan.
oh, just fast scan, not slow scan?
Slow scan is tiny. Slow scan fits in the bandwidth of a single sideband signal,
Right.
but it's really
But
slow. So,
so the question I have is that when I go look at that chart, maybe I'm just missing it, and I go look at the International Space Station and I look at what frequencies they're using for their slow scan,
mm,
it it seemed very interesting. It was like 48
right.
megahertz. Am
Well,
I
it's
right?
on 2 meters. They do
Yeah.
downlink of slow
Yeah.
scan, but it's slow. That's slow scan. It's slow
Okay.
scan audio over FM. Essentially, slow scan is just an audio, it's an analog audio thing. So you can modulate, you can use that as a baseband to modulate single sideband or FM, doesn't really matter.
Okay. But it's not for video.
And unless you want to watch really slow video. Sure.
Yeah. Gotcha. Okay.
So,
So, and is fast scan TV for video?
fast scan is what we would consider TV, 30 frames a second. But any high, so what we're going to cover today is anything that has a high rate of information. Video has a high rate of information. The more information you have, the more bandwidth it fills up.
Okay.
And by the way,
Yeah.
Jason, you're in Yakima, right?
Yeah.
You know Mark Tharp?
Mark who?
Mark Tharp.
I've heard the name, but I
Okay.
don't know him.
He's
Yeah.
uh he's the Northwest Division Director for the ARRL. He lives in Yakima.
Okay.
He looks like this. He looks like that.
Okay. Mark Tharp. I'll have to
Mark
look him
Tharp.
up.
Uh-huh.
Okay.
Yep. He's easy to find.
Yeah. I know. Do you know Rod Rath?
What's the last name?
Rath, Rath.
Um, I might by call sign, not
Yeah.
by name.
I don't remember what his call sign is, but yeah, he was the one that kind of got me into the GMRS and set me up with my first rig. And yeah, really helpful guy.
Let's see. Robert Raff. Call sign is. Oh no. Oh, let's look. RATH.
Yeah.
In Washington or otherwhere or elsewhere.
He's in Washington. He should be actually in this area.
Is it Selah? No, not Selah.
Yeah, that's
Oh, it's
right.
Selah.
Yep. Yeah,
Oh, Rodney Rath.
yep, that's
There he
him.
is. Okay.
He runs the .650 GMRS sitting on Sela Ridge there.
Looks like he rides a motorcycle.
Yeah. And he's got a really good repeater. That one's real healthy. It's nice.
Is this him?
Yep, that's him.
Yep.
Yep.
See, this is the international lookup.
That one's a
That's
lot faster than using the FCC one.
Oh
Good
wow,
Lord.
and this
It
one,
takes forever.
like people do their own bios and
That's
stuff like
cool.
that. That's neat.
QRZ.
QRZ.com. We say QRZ, so it's
Yeah,
QRZ.
I know. Well, that's
All
Canadian,
right.
isn't it?
Yeah, it is. Well, we say Z a lot, so
Do you? Little easier to understand.
yeah.
Yeah.
All right. So good morning. It's 9 o'clock. Time to get started. I hope everybody had a good night's sleep. I hope your brains are still pliable and not completely, cooked from yesterday. You had, you know, 16 hours to relax and 18 hours to relax and recover and questions are always good because if you like I said, if you had questions from yesterday, That means there are probably other people with the same exact question. So before we get going on anything new, let's talk about anything old that you just don't get. I think that's a good idea to cover it. So
Can
if you
you
do, go
can you
ahead.
just briefly run back through attenuation again, just like at a very high level?
Which part of it?
Um, just the general rules around it, if you can condense down.
Well, I mean, are we talking decibels or are we talking,
Yeah.
are we doing the math
Not necessarily the
or
math, just like some general thoughts around it. When you hear attenuation, what do you think of?
attenuation? Well, I mean, basically attenuation is that means that there's signal being lost somewhere.
Hmm.
Amplification is making a bigger copy. Attenuation is that. So let's say that let's say I have a circuit that looks like this, right? Okay, so here's my signal, and here's a something, and here's another resistor. And this has, let's say, 1 volt, and it's an AC signal. That could be RF AC. It's just some frequency AC. All right, and this is, let's say, 5 ohms, and this is 5 ohms. All right, so this is the amplitude of the signal over here. Right, so let's say it peaks at 1 volt. It goes down to -1 volt. So how much am I going to get across each resistor?
The same.
No, I'm
Um,
not. I'm going to have the same
oh,
current.
sorry. I was thinking of it would be, well, if you're flowing from negative, if
It
you
doesn't matter.
yeah, across each resistor would be actually
It would be half.
half. Yeah,
Yeah.
because it's just they're the same.
So I'd see this amount of voltage on this one and this amount of voltage across this one.
Yeah,
So I would see that each of them was basically half of the original size.
yeah.
So what's half in decibels?
Be
This number is going to come up every day if you're in RF.
Three.
3 dB. All right.
okay.
So that is a
Is it
loss.
minus 3
It's
dB?
negative 3 dB. It's a loss of 3 dB. So this number is actually really important because it continues to come up. So let's look at this. All right. This is a graph of frequency and let's say amplitude. What is amplitude, everyone?
It's the height of the sine wave.
The height of something, right? The amount of something. So let's say that this is a filter passband. So this is zero frequency and this is infinity. This is our, you know, perfect. This is 100% pass through and this is 0%. And our filter looks like this. So what does that mean in this area right here? How much
High,
of our signal is going to get through?
100%.
100%. How about over here on the right?
Zero, almost zero. If
Okay.
you're, yeah.
So what would you say the 50% number would be? Right about there?
Yeah,
Okay,
sure.
so we can do this and go like there.
Mhm.
This would be the pass band. That would be known as the pass band,
Okay.
right, of a band pass filter. How do we define this point right here as the edge? Well, it's 50% of the
Hmm.
of the peak, which means that half of it's gone. How many dB is that?
Three.
3 dB. We actually call this the 3 dB point. That
Okay.
determines that determines the edge of the pass band, and the speed at which it drops off determines the roll off of the filter.
Okay. So how steep it goes?
How steep it drops off. You could have a very
Yeah.
sharp pass band, or you could have a very gradual pass band. The
Hmm.
3 dB point right there defines the edge.
Okay.
Another interesting one is that we can have an antenna that looks like this, right? Okay, so we're going to do a 4-element Yagi. Okay. This thing is called, again, the driven element because it's actually a dipole. It's connected to your cable. This longer one is the reflector, and these are directors. Notice they get progressively shorter. These are parasitic elements that just basically are in the electric field and magnetic field that's generated by the driven element and resonate at the same time and force a signal which would look originally like this and be symmetric forward and backward, instead to look like this. And a shorter one and a smaller lobe in the back. So, how do you think we measure the beam width of this antenna?
By the amount of verticals.
Seems pretty arbitrary though, doesn't it? How do you think we actually measure the beam width in angle of this antenna? And I'll give you a hint. We just mentioned it a minute ago. How many
That's
decibels?
3.
Yep. So this is the 3 dB point, and this is the 3 dB beam width. So that comes up all the time. The fact that 3 dB is super important because it says it's half as good. So we measure antenna beam width as the 3 dB beam width. So essentially where it drops off drops off by 3 decibels.
So that what you're saying is that's kind of like our baseline or our standard that we
Yep.
look at.
3
Okay.
dB shows up everywhere. You
Okay.
will see it all the time.
And is 3 dB a point or the angle? I'm not sure I
What
get
is what is 3 dB?
It's well, it's decibels, so it's
What does 3 dB represent?
Half the
Elisa.
signal power.
Yeah,
the
Elisa.
loss 10 to the 2.
A ratio.
It's a ratio. In other words, 3 dB is half or 2 times, depending on whether it's plus or minus. This
Yes.
is so basically a gain or loss of 3 dB represents either double or half of the
Okay.
of the original. So if we have at the peak a signal that's way out here, and at the 3 dB point we have this, there is half as much power going out this way and this way as there is right up the middle. That's how we name our 3 dB beam width. In other words, we say, at what point does it work half as well as right down the middle?
and
And
that point is
and
published.
that's called the 3 dB point. Yeah. And
Okay.
they'll say that's or they'll just say antenna beam width is 22 degrees. And you know that if they're saying antenna beam width, it's specifying the 3 dB beam width.
Okay.
Now there's also, you note, something here. Here's the forward lobe. This is the stuff you want going forward. And here's something in the back.
Yeah.
That's actually called the front to back ratio.
Mm.
How do you think that's measured?
Decibels.
In decibels. Yep. So the better the front to back ratio, the more power goes forward compared to going backward.
Is it the first number, the front, and the second colon, the second number is the back, or
Yeah.
versa? Okay.
It's the front to back ratio.
Okay. So if you see a 2:1,
That would be 2 to 1. So you have essentially twice as much. You
Going up.
have that would be well, 2 to 1 would be 2 dB. If you have a 3 dB ratio, that means how many times more power is going forward?
twice.
Twice as much. And in fact, when you look, if you look at an antenna guide, what you'll see is that you have like a 0 dB circle. What does 0 dB mean?
It means 0, nothing.
No, it means 10 to the 0 power,
Oh, yeah. Okay.
which is
1.
1.
1. So that's the unit. So this
Okay.
is
That's our base unit.
that's
Yeah.
your baseline.
Yeah.
So a dipole would have an antenna pattern that looked like this.
I've seen that. Okay.
Yeah. So that would be 0 dB gain over a dipole because it is itself a dipole,
Hmm.
right? As soon as you add a gain element, might look like this. And here's the backward lobe. So
Oh, okay.
now your front to back is defined by where this intersects. And your gain is the green dot compared to the blue dot.
No,
And these will be marked with lines. So
okay.
there's that says 0 dB, this says 2 dB or 3 dB, this says 6 dB, another one would say 10 dB, and they just be kind of concentric circles
Okay.
that
And obviously
continue
they
outward.
drop off as they go because your gains decreases, right? As you move out.
Well, I mean, let's say that you add more elements and your new antenna pattern looked like this. So that'd be like,
Yeah.
9 dB
Yeah. Okay.
gain
Because you're
compared to
looking
the
at that.
original antenna. It's
Yeah.
compared to the original antenna.
Yep.
Remember, because it's a
There.
ratio. So
Got it. Okay.
Now, how do you actually measure this in the field?
how do you measure it in the field?
Yeah.
You use a field strength meter,
Field strength meter.
which is literally an antenna with a meter attached to it.
And you walk around
And
and
you walk around.
graph it.
Yep.
Ah.
Now, the other way to do it is that you use something called, hey, I found the classic whiteboard. Ah!
It only took you a day. I mean,
It
come
only
on,
took
man.
me a whole day. They couldn't tell me where to find it, but there it is. Okay. So, wow.
Yeah,
You have to
I
do share. If you do share, you do it. If you click whiteboard, it doesn't work.
what's wrong with the other one? I
Wow.
kind of like the grid.
Yeah. Okay. Well, I'll do that. How about that? Let me see if I can get out of it now.
But you're also fine where you're at. You don't need to acquiesce.
Where's the
Yeah.
unshare button?
Yeah. Now I like the new one.
Yeah. Right.
I don't really
Yeah, I
like
mean,
the new
aren't the
one
grid
yet.
dots kind of nice? Because then you have referential points and
Yeah. All right. So let's see. Before I was so distracted by that, what was I saying?
You're
Front to
talking
back
about
ratio.
measure in the field, and there's another device that
Oh yeah, yeah. Okay. So essentially what you're looking for is a way of measuring field strength. So there is something called NEC. And that's not National Electrical Code. That is the Numeric Electromagnetic Code.
Hmm.
NEC was developed in the early 1970s to do antenna modeling. And it was written in Fortran, and I believe it still exists in Fortran. It has not been updated a whole lot because they did such a good job of it. But that was developed by the government for free, for use by anyone, and it has been incorporated into software called 4NEC 2 and EasyNEC and a few others. And essentially, it still uses the original and number crunching code, but it runs on your PC, and it also
Yeah.
will generate a three-dimensional graph. So let's say that you created a wire, you modeled up an antenna, and let's say that you devised something that looked like this. So here's the ground, and here's the 3 dimensions. You devised a piece of wire that looked like this, and the feed point was way up here, and here's another one, and here's another one, and here's another one, and then there's something going this way and something going this way. Kind of a weird looking antenna, right?
Mhm.
And this is, a certain number of feet off the ground in each place, and you manage to be able to support it from a central support. So here's some funky new antenna that you came up with, right? You can actually go through and model all the wires using the software. And what will end up happening with this is that you say, okay, now run it and give me a frequency scan from 0 to 30 megahertz. And it will produce a chart after a couple of minutes, maybe, that looks like this. So here's your standing wave ratio versus frequency, and it might look like this. Essentially, what it does is it looks at every segment of wire and the current that it's carrying and figures out what that does as far as the antenna's performance and feeding it into it and looking at the impedance and seeing how it works. You can also say, show me a map of my let's see, what would I say in this case? Um, Show me return loss. Another one you could do is say at a particular frequency, show me what my transmitted pattern looks like. And the way it does that is it picks a place and combines the contributions from every one of these little wire segments and the current that each one is carrying at any given frequency. So it figures out kind of like what we drew yesterday at every point and then runs around in circles and up and down and says at any point in space, this is what the antenna looks like. And what it does then is it gives you a nice three-dimensional pattern map
Hmm.
with false color, indicating how strong it is in that direction.
Huh.
Free,
That's cool.
totally free.
Wow.
All
That's
it
cool.
takes is if you feel like learning how to use it, it's incredibly powerful. If you want to design your own antenna and then try it out, it gives you a great starting point for what you're going to end up with.
Is
And
it
then,
graphical or is
yes,
it
graphical.
okay, awesome?
And the other cool thing beyond that is that you can say, okay, well, show me. I have like these two wires and I don't really know how long to make them. I'm going to say I parameterize the length of these wires, do an optimization based on peak gain, and it'll run through and iterate it and eventually hopefully come up with something that, you know, stabilizes at a certain length and it'll say, here's the optimal length for those wires.
Wow.
Yeah,
So
totally
you could
free.
run that instead of going long and cutting back,
Well, well,
technically run that instead.
it's really good for experimentation if you
Okay.
don't know, even if you don't even know where to start.
Okay.
Because
Hmm.
what ends up happening is if you don't know where to start, you really don't know where to start. But if you're going to come up with something that is novel and new and say, does this even stand a chance of working? What would it possibly do? I have an idea in my head,
Yeah.
but but to build that, you know, you could spend days putting that up in your trees or putting it up on a pole, and it might never have worked in the first place. This is a way of seeing if there's even a chance that
Sure.
it's going to work.
Sure. Hmm.
So antenna modeling, really cool stuff.
If you were to just think about like, when people are designing antennas, what are maybe the top three things that they always look for? Like what's in their head? Okay, I need to know this, this, and this.
Can you
If I
feed
can
it?
boil it
Can,
down to three.
can you feed it? Can you
Mhm.
mount it? Can you build it?
Okay.
I mean, is it even possible to build? You know, I mean, sometimes you come up with a really cool antenna. Like I would love a 160-meter antenna, right? Wavelength is 500 something feet. I don't have room for that. So how do I go about building an antenna that I intentionally shorten up
Yeah. Okay.
in a way that it doesn't hurt me too much? And in
So
fact,
you say, sorry, go ahead.
the gain might be, my peak gain might be negative 6 dB, but it's better than nothing if I never built it in the first place.
Right. Right. And then you can do some giz wizardry a little bit to try to,
Maybe, maybe,
monkey it around a little bit. Maybe. Yeah.
maybe. Yeah. It's really, antennas are the one place where you can do so much experimentation and it doesn't really cost that much.
Yeah.
It's just wire.
That Bob Fung, have you ever played around with that?
With
I
what?
don't know if it is. I think it's Bob Fung. He's a big, super smart guy. But he came up with a dipole that you can
Oh,
build yourself. You know that one where you bend one side a little shorter than the other one,
yeah.
and you can put it inside of a piece of conduit.
Ed Fong.
Ed Fung. There we go. Thank
Mhm.
you.
Yes.
That's
Yeah, it's
pretty
quite
cool.
popular.
Yeah.
Yeah.
And that software is called what?
Well, there's
Is it-
4 NEC 2, like number 4 NEC 2, and there's also Easy NEC, Easy NEC, and there's probably some others out there.
What does E stand for again? Sorry, I missed that.
Numerics, electromagnetics code.
um,
I'll put it in the chat. Easy NEC and 4 NEC 2. Those are just 2 of them that are free. All right. Other questions before we get going?
Yeah, yesterday I couldn't tell time. I started late. What did you talk about the first hour? I apologize to you too.
The,
Or do you want to skip it and go later?
there is the video.
Yeah.
He sent us a recording of the video too.
Because the first hour covered a lot of stuff.
Okay.
So, other questions? No? Okay. So, remember I said yesterday that I typically see about a 50% attrition rate?
Yes.
So kudos to all of you for not attritioning. So I know it's a lot of material.
I was
But,
definitely watching
Thank
that,
you.
going,
Yeah.
I wonder if that's going to be right or not.
Yeah. All right. So tell you what, we're going to cover a quick chapter and then we're going to do something a little bit different. Just a little bit different. All right. So the first thing we're going to do, again, we're going to follow a little more closely with the book today because I'm still going to be bouncing back and forth between the book and the chart, but I wanted to show everybody this, right? This is something that I sent you all,
Yeah.
right, in that packet. Okay, this is the very simple and very overviewy United States frequency allocation chart. So if
That's
you
on
ever
the test, that right there.
parts of it,
I'm just
So,
kidding.
yeah, no, parts of
Hopefully
it.
not the whole thing.
No, not the whole thing. But I would like to point out that there are 3 things that I can guarantee will be on the test. At least one of them for each of you. I don't know which one. I don't know who's going to get what. But notice that we have 3 megahertz. And notice this one is 30, and this one is 300. This one is 3 gigahertz, then 30. What do you notice about all of those? Each one is
3.
10, and it's 10 times bigger than the previous
Yeah.
one.
Mhm.
So,
Yes.
So this is very important. I mean, this is very important to the fundamental understanding of what it is that we're doing. So let's take
Can
a
you
look
say it
at
again?
which one.
There's something I'm not computing. I'm looking at it on my own as well and enlarging it. And I clearly and obviously understand you're seeing it go 330, 300, and that makes sense. But when I look at the one I have, I don't think I understand because starting at the top of the one we have, it goes 300,
Right.
330.
I just ignored that section.
Okay,
So,
okay, thanks.
Okay. So we can look at 300 kilohertz up to 3 megahertz. We can look
Okay.
at that and see, okay, well, see this thing that says AM radio right there? That's AM radio. It's a very long wavelength. Now, notice that AM radio also takes up more than half of that swath, right?
Uh-huh.
That blue section.
Uh-huh.
Well, how big is that swath? It starts at 300 kilohertz
Uh-huh.
and ends all the way at the right at
260 megahertz.
at 3 megahertz, which is 3,000 kilohertz. So it's 2.7 megahertz wide.
2.7. Yeah, I had the decimal wrong.
Okay, so let's look at the next one down. This is the band that goes from 3 megahertz up to 30. How many megahertz wide is that?
27.
27. Yeah. This is the high frequency band. This is HF. From 3 to 30 megahertz is the high frequency band. And its total space is 27 megahertz. How about the next one? From 30 to 300.
270.
270. That is the VHF band. There is 10 times as much
Wow.
space on VHF as there is on HF. And
That's
how
a
about
good-
on this band from 300 megahertz up to 3 gigahertz, which is 3,000 megahertz?
so
2,700.
2.7
megahertz, exactly. 2.7 gigahertz. This is the UHF band. And notice that right in the middle of this is TV broadcasting, channels 21 to 36. And up here is more TV, and then there's more broadcasts and stuff like that. Well, each of those TV channels is 6 megahertz wide. It is wider than the entire
swap.
300 kilohertz swap
Yeah.
where AM radio is. So this chart, when you look at it, you need to keep in mind that the way that it's laid out is that it's a logarithmic chart,
Mhm.
that each band is 10 times bigger than the one immediately above it. So that means if you want to find a band that has a ton of space in it, a ton of bandwidth, where are you going to go?
You go higher.
You're going to go higher in frequency, which is way down at the bottom. Notice this one that says 30 gigahertz. All the way at the right-hand side, it's 300 gigahertz. That's 270 gigahertz. Look at all the different services that are in there. Those are also frequencies that punch right through the atmosphere. So you'll see a lot of space exploration and satellite, broadcast satellite, things like that.
Did you say that UHF was 3 to 30
Nope. Here we go.
megahertz, and it was 300 to 3 gigahertz was UHF?
3 to 30 is HF, 30 to 300 is VHF, 300 to 3,000 is UHF. And that's, just have to memorize those. I guarantee one of those is going to be on every test.
One of what the whole
The naming convention. That 3 to 30 megahertz is HF, 30 to 300 is VHF, and 300 to 3,000 is UHF.
So the question would be like, what is the frequency range of UHF?
Yep.
Okay.
Or what do you call the 3 to 30 megahertz band?
Okay.
Where do you see on this thing that I've just enlarged? I have to look on my piece of paper and kind of look back at the screen. Where do you see it say, for example, UHF, VHF?
You don't. I'm telling you.
Hmm.
Now, I will say that it's also on another thing that I sent out, or that I see, I have to share this. There.
Scott, if this is the cheat sheet, oh,
That one.
I have a question on it.
Okay, that's the electromagnetic spectrum. And there's your HF, VHF, UHF. 3 to 30, 30 to 300, 3 to 3,000. Commit it to memory.
From 3 gigahertz to 300 megahertz, is that 2970 remaining or 2700 remaining?
From
3 gigahertz minus 300 megahertz.
So what's another way to say what 300 gig or what 3 gigahertz is?
It's
It's
millions minus thousands.
Well, it's 3,000 megahertz. 3 gigahertz is 3,000 megahertz. So then 3,000 minus 300 is 2,700 left.
Okay, thanks.
So if somebody wanted to build a network for, high speed internet, where would they put it?
Up high.
You would put it up in the really high frequencies where there's tons of bandwidth. And in fact, if everyone's familiar with the Trump administration's big, beautiful bill that just got approved, a big part of that is trying to take over a lot of those, very high frequency UHF signals and above for redeployment and for auction.
For what?
Auction.
Oh.
Wow.
Uh-huh.
Isn't it to give it to Elon Musk?
Who knows? Maybe. It's not to give it to anyone, but it's
Well,
to
to sell it.
make money off of it. And I would also like to point out that it's one of the reasons that we have something called the American Radio Relay League is because Congress is going to do what they want as permitted by international treaties. But I would like everybody to notice what you see up here, even in the 3.3 gigahertz range. What does that say right there?
Amateur.
Okay, and let's look at the 5 point something gigahertz amateur band, and up in the 10 gigahertz, which is like X band radar, amateur, and we go down into here, and what do you see at 76 gigahertz?
Amateur.
Amateur satellite. We actually use those. We're actually allowed to do all kinds of experimentation with those, and those are on the sale. Those are going to be on the sale block too. So we have, you know, most hams don't use those frequencies, but they are there. We do control satellites. We do put up satellites. And so the ARRL, we have lobbyists and lawyers on Capitol Hill that explain to Congress what we do and how we, you know, how we make things better for people and give them room to experiment. And not everything is for sale, we hope. So
Wait, I don't
we will
understand
see.
why there's not from ARRL some kind of a huge, amazing, big, like letter writing push or thing where we all click and it sends letters to our senators, representatives, and this kind of a thing on is ARRL.org doing something as a push for like don't sell our stuff? Are you kidding me? Like, what are you doing? Like,
Well, yeah,
it's
but who's gonna? Well, okay. How much do you pay for a license?
It's $35 every 10 years, but
Actually, the $35 is just for processing fees. How much do you actually pay to have your license?
I guess nothing.
You guess nothing. That's right. We pay nothing. How much would an internet broadband company that wanted to use a microwave frequency pay the FCC to be able to put up a bunch of satellites and stuff? 20 billion? It's a hard sell. It's a hard sell. We have to, part of it is that we have to show that there is tangible evidence that we are doing something for the public good. That even though there's not money to be made, it's the right thing to do. Ha ha ha. Good luck with that these days, right? So the ARRL is out there and doing exactly that. You know, when we do um when we do public service, we're supposed to report all those hours. We record and report all the volunteer hours that were given in service of the public. You take those numbers and you report them to the ARRL. If you're not a member of ARRL, it doesn't help. So, it's essentially, think of it as a crowd-funded organization that is protecting frequencies and standing up for hams everywhere, right? But remember, we don't pay to use the frequencies, so it becomes a hard sell. They
Well,
take all those hours. They take all those hours and they aggregate the costs and say, we did $2.5 billion of service to the public with our free frequencies last year.
Yeah.
So,
and don't think that, Verizon and T-Mobile and all those don't have lobbyists up there going, hey, yeah, we want that frequency.
They have infinite lobbyists with infinite budgets.
Yes.
We do not.
That, when you look at bandwidth, man, when you just read about it, it's like it's better than gold. The value behind it is astronomical.
Exactly. So that is my plug. When you get your license, it is really, really good to join ARRL. Even if you don't agree with all their policies and all the way that they do things, and every organization has internal strife here and there, but you know what? It's been around for 120 years. Wait, 110 years. And the ARRL, of which basically we are all, as hams, we're encouraged to join, stands up for us. And no, we don't have billions of dollars for lobbyists. So
Scott, I have a question.
Yeah.
So I was looking at page 2 of the cheat sheet.
Page 2 of
And
the
I was
cheat sheet. I have to go back and look at the cheat sheet.
This was a black and white version. There's a version that's in color. It's kind of rotated, but it shows the bands and it shows by license class who can use what at what point in license.
Yeah, okay. That
So
there's a better cheat sheet, which is the band plan. And I'm gonna share that if I haven't already.
so the simple version of the question is, I get a technician's license.
Mm-hmm.
What do I get? Or maybe a simpler answer would be, what aren't I able to do and
Okay.
where?
Okay, so this is going to be on the exam. Technician class operator has all privileges above 30 megahertz, for one thing. For every band above 30 megahertz. You want to operate satellite frequencies at 76 gigahertz, you're legal. You can operate everywhere above 30 megahertz. Notice where it says VHF, UHF. So you can operate anywhere in VHF, UHF where there are privileges. On the HF bands, you have to look down here where it says novice and technician CW, novice and technician voice, which are those hatched areas, and those are the only allocations you have on HF.
Is that in our kit?
I don't see
Yeah.
US dash blah, la, la. I don't see that. I have all of the ones. I have 12, but I don't see that one.
What, the frequency allocations?
That
US band plan
one you're
update.
showing right now. Yeah, US band plan.
It should be there. I'll
Didn't
show
there?
here's all the stuff that's in that, and it's US band plan update.
Interesting.
And if you don't have it for some reason, you can always
Oh
download
no,
it.
it did. It didn't. Thank you.
Hmm?
Mine
Oh.
looks like yours now.
Yeah.
So that 28.5 is enticing to me. Just to get the technician and have voice on HF.
28.3 to 28.5. Yeah.
Yeah.
But okay, so one of the things we talked about was that during sunspot peaks, we get
Yep.
enhancement on 10 meters and 12 meters and 15 meters because we get a lot of solar activity. For the next 8 years or so, 10 meters will essentially be dead all the time. Do not bank on 10 meters as your fun band. Get your general.
Okay.
Because your general, you get access to everything.
Yeah, I thought that now maybe I'm mistaken, but I'm sure I am. But I thought that we still had some time there, a window of about another year or so before
It's
start
going
closing.
downhill.
Yeah, right.
It's
When I
on the
looked
way.
it up online, they said July 2025 will be the end of its peak.
Yeah.
End of
Yeah.
its peak. Right.
Right, but it's going downhill. I mean, there'll be little bumps when it becomes good again.
Yeah.
I noticed on that chart it said it had it had technician, general, advanced, and then extra.
Uh-huh.
I thought there were just 3, or are there 4?
Well, there are actually 5. You can only get 3 different licenses now. You can only get a technician, a general, and an extra. However, if you previously had a novice or an advanced license, you still have it. It didn't get they
Okay.
didn't get grandfathered into anything else. That was very astute. There are still a lot of people out there with advanced class licenses because it's, an anomaly. They want to be different. So other questions? This is great stuff. Nothing? Okay. Here we go with back to the book if I can find it. There we go. Okay, RF hazards and radiation exposure. All right, this is why you need to go through the process, and we're on page 70, of figuring out whether or not your station is safe. Based on that frequency spectrum chart, based on the electromagnetic spectrum, X-rays, ultraviolet rays, and basically anything shorter wavelength and higher frequency than visible light has enough energy to cause ionize atoms which can cause genetic damage. Radio waves, very low energy. They can cause heating by heating up water, for instance, in the microwave range, but they are non-ionizing, which means they don't cause DNA damage. Who's responsible for ensuring that no person is exposed to RF energy above the limits? Station licensee. So it's important to note that there are two parts to a license. There's the operator license and the station license. A station license does not have any privileges at all. It just gives you the permission to put up a station and give it a call sign. But it doesn't have any privileges. So whoever is the station licensee is responsible for ensuring that the exposure limit testing or calculations have been done. Duty cycle, this means if you're talking for 10 seconds and then not talking for the next 90 seconds, that's 10% of the time, so you have a 10% duty cycle. Duty cycle is important because if that is your expected mode of operation, it changes the average exposure. The average exposure is actually part of the calculation. If you have a repeater, for instance, that's repeating everything that it hears and there's a net going on, that would probably be 100% duty cycle. So that changes the calculation quite a bit. So if you change your duty cycle from 100% to 50%, that means you can run twice as much power when you are transmitting to get the same average power. The human body absorbs more RF energy at some frequencies than others. And that is why when you do those calculations, the limits change, the exposure limits change with frequency. 6 meters is actually the peak of our ability to absorb radio frequency energy. What factors affect the RF exposure of people near an antenna, near an amateur station antenna? Well, how far you are from the antenna, what the pattern looks like, and the frequency and power level. What do you do if, and this was the question that came up yesterday, if you find that you have too much exposure to RF, you can remove the antennas, get them further away from people. Typically, even if you're running 1,000 watts, if you have a 200-foot tower, no one's going to get any kind of radiation exposure. Nobody's, unless they're climbing the tower. If you change anything, antennas, transmitter power, anything like that, you have to do another evaluation and keep hold of it. Okay, station setup and operating controls. This is basically the next part of building a station. How do you build a station so that it functions well? This is essentially like good engineering practice. So, why do you use big, fat, heavy wires? You use big, fat, heavy wires because of Ohm's law. And what does Ohm's law do? What is Ohm's law, everyone?
E equals IR.
Okay, so by using big, fat, heavy wire, what you do is you reduce your R. You reduce your resistance, which means that your voltage drop goes down. The bigger and fatter and shorter the wire is, the less resistance it has. Notice that we now have a 50-watt transmitter. If I were to tell you that your efficiency is 50%, in order to make 50 watts of radio frequency output, how much power would you need coming into it?
100 watts.
100 watts, yes. Okay, so let's look at, we don't use 24 volts, but let's use 13.8 volts at 4 amps. What's the other part of Ohm's law? The power part? Everyone? P is equal to?
I times
E. P is equal to I times E. So 13.8 is your E, 4 amps is your I. You multiply them together, you get about 55 watts. Is that enough to run a 50-watt radio?
No.
Not if you only get 50% efficiency.
That's right. And most radios are about 50% efficient. Okay. What signals are used in a computer radio interface for digital mode operation? Okay, so you have to get audio into the radio, you have to get audio out of the radio, and you have to somehow key the transmitter to make it go from receive to transmit. So the radio receives audio that goes into your microphone input on your computer. The radio has to transmit audio. That's a speaker on your computer. And there's actually like a relay that turns the transmitter on. For FT8, the important thing about FT8 to remember is that FT8 is part of this WSJTX software package. WSJTX has about 15 different software modems built into it, the most popular of which is FT8. All right, computer line in. Okay, very important now. We're going to talk about, and it's so important that I'm actually going to do another share of a whiteboard. Yes, the new style whiteboard. All right. So what exists around this piece of wire if there's current flowing through it?
A magnetic field.
A magnetic field. Yes, very good. Okay, so we have a magnetic field going around in circles. How about if I coil this up? Do I still have a magnetic field?
Yeah.
Sure.
Yep.
Except that the magnetic field now looks like this. It makes loops like that. What if I were to take that magnetic field then and say, I want to take that current and make that magnetic field essentially destroy the current. Because on that current, I have part of that current, I have AC and I have DC. And I only want the DC coming out. This is what's on your power supply for your computer. If you look at your computer power supply cable, you will see that somewhere on it, it has, wouldn't you know, mine does not have one. Huh.
Some do,
Wonder
some
why.
don't these days.
Oh, wait, there we go. There we go. It's just small. Here we go. I found it. Okay. Does anybody see, if you look at your computer supply cable, one of those?
Mm-hmm.
Okay. Any idea what that is?
That's a magnet, isn't it?
Nope.
That's the ferrite choke.
Ferrous core.
That is a ferrite core. Okay. So what a ferrite is, usually it can be made in any number of different shapes, but the simplest one is a long tube that's hollow like that. And a wire, you take it and you snake it in and you run it through the other side. That magnetic field that exists, it exists in air very nicely. However, this material right here is made of glue and iron powder and maybe some manganese and some nickel and a few other interesting metals, which are all ferromagnetic. So this is the same type of material that you would use to make a transformer core. In this case, these are all ferromagnetic materials, which means that if you have magnetic fields floating around out there, they tend to get concentrated in this core. The core is also designed to be attenuating, there's that word again, at certain ranges of frequencies. So let's say you know you have RF floating around and you want it to attenuate anything that exists because you have lots of different frequencies on this wire that's coming into your computer. Lots of different frequencies. And you can't control them because they're being picked up from the environment, especially if you have a radio transmitter nearby. You pick the mix of metal powders that you bake into this shape so that it attenuates anything greater than 1 megahertz and burns it up as heat in the core. So if you're burning up all the energy at a frequency greater than 1 megahertz in the core, what's coming out the other side?
Everything less than 1 megahertz.
Which is basically the DC that you're looking for. Because you had DC plus RF going in on this side. That is the point of a ferrite choke. a choke.
And this is connected between which components?
This is, for instance, if you look at your computer power supply, the cable going into your laptop, there's one on the cable right there. It's designed to attenuate, and I'm sure the measurement for attenuation is in what units?
Decimals.
Decibels.
Yep. This effectively is a form of a low pass filter. It allows low frequencies like DC to get through while attenuating higher frequencies.
That way all our houses don't have big giant radio transmitters in them and we didn't even know it.
Well, yeah. So the other thing is when you start looking at ferrites, what we're going to do is we're going to go to a company called Ferrite. Yes, that's a nice play on words, right? And let's share their page. Ferrite makes great stuff.
Brought to you by Ferrite.
Brought to you by Ferrite. Oh, what do you think Ferrite specializes in?
Ferrite cores.
Ferrite cores. Look at that. Ferrite components for the global electronics industry. And a big part of what they do is suppression components and ferrite beads through holes. Notice they have all kinds of different shapes and stuff like that, but notice they have different materials. 44, 52, and they have, there's actually dozens of different combinations of materials. So very interesting. Here's, impedance and stuff like that. And yeah, different shapes, different sizes. Let's see, wound ferrite beads, ferrite chip beads, differential mode, EMI suppression ferrite beads. Oh yeah, look, there we go. Look at all those different materials. 43, 61, 73, there's a 75. These are all different materials that have different characteristics at different frequencies.
Notice they're trademarked. I bet you
Yep.
there's a little secret sauce in there.
Oh yeah, it is. It's basically metal powder mixed with glue and baked into a shape. They make all different shapes, they make all different sizes, and they're useful for incredible numbers of different things.
So on the question, why is ferrite core more appropriate than a low pass filter?
It is a form of a low pass filter depending on how you build it. And they work.
Yeah, but the question on the test that you were showing before this included that as a...
Which of the following would you use to cure distorted audio caused by RF current on the shield of a microphone cable? The important thing is, notice it's on the shield. Okay, this actually brings up a really good question.
Mm-hmm.
All right, so I'm gonna draw a cable. See, and this is why class is not 2 hours long. This is why class is a lot longer than that. Okay, so here's the shield, and here's the center conductor. And there's an insulating material in here. How many conducting surfaces are there?
At least two.
There's not two.
Oh, one.
Nope, there's not
and then
one.
a shield, right?
How many conducting surfaces are there?
3?
There's 3.
I'm still updating the whiteboard. I can't see what you drew yet.
Okay. There are 3 surfaces. One is the outer conductor, is the outer portion of the center conductor. That's number 1. And then I'll draw this on the other end. Number 2 is on the inside of the shield because it has a little thickness. And number 3 is on the outside of the shield. And these do not have to be equal to each other. 1 and 2 are typically going to be equal and opposite. Those are balanced. 3 does not have to be. And the reason that is true is because at radio frequency, you have something called the skin effect. At any AC frequency, you have something called the skin effect, and it's very, very pronounced at radio frequencies, where most of your current at a given frequency travels on the outside of the conductor. And because your shield has a finite thickness to it, it's not infinitely thin. It has an inside and an outside, and those can carry different currents. So if you have number 1 and number 2 equal, and number 3 carrying something that it just picked up from the world, what you do is then you take your ferrite core and you wrap it like this. Or you can also take it and use a donut shape and go like this with your cable and wrap it around it a bunch of times if it's a small enough cable. And that will attenuate signal number 3, which can cause distortion on your signals. And that is exactly why it works so well for your computer power supply.
So is that why they got the new Cat 7 cables that are individually wrapped?
You know, I don't know. Is it?
Yeah.
Is that
I
what it
think
is?
so. Yeah. Well, carry more bandwidth.
That's more for crosstalk, right? Because
Yeah.
you can
Well, that's
only get so much from twisting them.
Mhm.
But it also increases your I guess gain the power.
Well, I would think that it depending on if they're individually shielded, it reduces the amount of crosstalk between channels.
Right.
But I think the twisting reduces crosstalk across the pairs that are inside.
Yeah, it does.
Yeah.
Okay.
Is ferrite bead, choke, and core all used interchangeably?
Yes. It really
For
comes
our purposes.
Yeah, and it really comes down to the shape. So, but they're really the same. A ferrite bead, ferrite core, it's shape and size. So, and they can all be used in the form of a ferrite choke. Now, because they can also constrain magnetic fields. We also use them as the basis. If there's like 2 holes or a really big one, you can wind 2 cables around it or 2 wires around it. You can use it as the basis of a transformer. So that's why they sell them as, magnetic materials. Which of the following conductors is preferred for bonding at RF? Okay, so we just talked about the skin effect, right? Where does most RF energy travel?
On the outside.
On the surface of the thing. So, which one has more surface area? A round cable or something that's squashed flat?
Black copper, yeah.
Flat copper. That is why we use flat copper strap for bonding at RF. Because it has more surface area, so it has less resistance. See, all this makes perfect sense, right?
Yeah.
Right? It all comes down to physics.
Mm-hmm.
Where should the negative power return of a mobile transceiver be connected in a vehicle? The answer is at the battery ground. Why do we go to the battery ground?
Because because if you could have a floating ground if you ran it somewhere else.
Well, hopefully it's not floating, but let's ask a question. Here we go. I'm going to draw a very rudimentary looking car. Please don't laugh. My drawing skills are very bad.
We
Okay,
already
so here's a wheel.
Don't
Yeah.
worry about it.
Yeah. Was it the picture of myself that clued you in?
Yeah, exactly. Yeah.
Okay, so here's a car. Okay. And inside this car, you have a battery with a plus and a minus. All right. Usually the minus terminal is grounded to the frame of the car.
Yeah.
The plus terminal goes to, let's say.
Was your question body or frame?
Well, the same thing.
Are they?
Yeah. So let's say we have a light with a switch. The light is given power right here. And typically what happens is that the negative terminal is bonded to somewhere on the frame. So what is the return path for current back to the battery if you do that?
Through the body and then
through
back
the body of which is fine, except how much current is this designed to carry?
Yeah.
The answer is, I don't know. So let's take that light and replace this with a 22 amp radio. So if that is, we turn it on, we use our 22 amps. How does the 22 amps get back to the battery?
Through the body.
Through the body of the car, right? So
with resistance.
Is the body of the car designed to carry 22 amps at very low resistance? I have no idea. I didn't build the car. I don't know how good of a job the robots did when they welded it. So this is a bad idea. That's why we don't do that. Instead, what we do is we run a wire just directly back to the battery, specifically for use by the equipment.
In theory, we were to measure the current on something that's wired first way, going to the body. In theory, you should see a higher current draw when we might see the mic, correct?
Oh yeah. But still, what would happen is, let's say that you had a high resistance, and in the process of doing this, you ended up with a 3-volt drop. Well, if the battery is only at 12 volts in the first place, and you have 12 volts coming here and 3 volts loss going back, how much voltage is available to your radio?
Yeah, 9.
9 volts. And what will happen to your radio at that point?
Not happy.
It'll shut off.
Yeah.
So that's why we run a big cable back to the battery as ground. Okay, how do you determine battery capacity? We use something called an amp hour, which is an ampere being able to be delivered for 1 hour. So if a battery is capable of delivering 1 amp of current for 1 hour, it has a capacity of 1 amp hour. I have a 100 amp hour battery in my garage, a lithium iron phosphate battery. That can deliver 100 amps for 1 hour in theory, or 1 amp for 100 hours. That's a little more likely for what I plan to do with it. Operating controls. Now, this will be a very common theme: distorted transmitted audio. You will see that if you see that answer, it's probably the right one. Because distorted audio is a very common problem, and it sounds really bad, and there are a lot of things that can cause it. So too much microphone gain. Like me doing this.
Yeah.
Right? Sounds bad, right? Distorted audio. If your FM radio, for instance, your handheld radio is tuned off frequency, it will sound distorted. Which of the following can be used to enter a transceiver's operating frequency? Most of them do have a VFO knob, which is a variable frequency oscillator. There's also a keypad. So with that, if it's still there, I'm going to stop this share and open my, hopefully, WebSDR.
What was the O again? VFO?
Oscillator.
Oscillator.
It used to be that it actually was a physical oscillator, a tunable circuit, like a tank circuit. Okay, so can everybody hear the sound?
No.
Okay, let me make sure that I can make sure I turn on the sound. Share sound. There we go. You hear sound now?
Yep.
Okay. Here we go. Changing the frequency. Direct frequency entry. If I had a knob attached to it, it would do this and just slide it up and down. Essentially, this is a tuning knob. And what's the point of a tuning knob?
To get you the right frequency.
Gets you to the right frequency. Okay, so when we're looking at this, this is called a waterfall display. And yes, I know the water is falling in the wrong direction, right? The water's falling up. But this is a way of visualizing. This is a way of visualizing frequency, amplitude, and time. The intensity of the signal is shown by the brightness of the color. The time axis is as it's falling. You're basically looking further and further down, I guess. And the frequency is shown on the axis below. So 21 to 2105. We can zoom out. what's cool about this web SDR is that we are now looking at the entire 0 to 30 megahertz spectrum in one fell swoop.
Hey, Scott, you know your
Yeah.
little swath there that you have in the yellow?
Yeah.
How come when I was playing with it, I could only go so far? Is there adjustment to, you know what I
You
mean?
mean
To where I
you-
can grab it? Yeah,
you
right there
can
like
do
that.
Yeah.
But
It only goes, yeah, it's limited in the amount that it can receive.
is there an adjustment there, or is that just hard coded in
It
there?
looks like it's hard coded
Okay. All right. Fair enough.
because you're basically listening to something that goes above 6.5 kilohertz. So I guess 6.5 kilohertz is its max.
Okay. I
Um,
did get the I did get a baseball game yesterday on AM.
Excellent. On the SDR?
Yeah.
Yep. That means it was also after dark.
Over
Because
there. Yeah.
yeah, exactly.
Yeah.
Okay, so this is a software defined radio. A lot of radios today are software defined, but they have every radio has the same basic controls. Now, because we're looking at a waterfall display, we're looking at a range of frequencies, right? They go from low frequency on the left to higher frequency on the right. This is no different. It's a little hard to wrap your head around sometimes, but this is no different than this.
Scott, are we supposed to be able to do the little thing you're doing with the tuning, or are we not supposed to be able to go there?
If you open up WebSDR and go to any of them, you should be able to tune them from your computer.
WebSCR.ewi.
I
think it was websdr.com.
Well, and this one is yeah, it's the one in the Netherlands. I'll just put it out there. This is
because I think when you go on the front end, you can pick where you want to.
Yeah,
like,
there are hundreds. WebSDR.org has hundreds
There you go.
of
That's what
SDRs to pick from. But the top one is the one in the Netherlands that works really, really well. I mean, it's a favorite all around the world because it works so well. And
I just looked at how many users were on each one and thought, oh, that's got to be the one.
Yeah, this one, according to right now, has 770 users around the world.
Yeah, versus some of the others that have 20, 30. Yeah. Maybe.
So, let's see. So as far as so that's right. Let me unshare that and share this. So that is really no different when you're looking at that display of frequency versus time. When you tune to a different frequency, the analog is you're really looking at a very slightly different color. And the further you zoom in, the more precise color you can get. Each particular frequency represents a different color of wavelength or color of radio wave. Just the same way that each color represents a different wavelength of light, because they're really the same. It's just that we don't have the ability to see them or hear them. But the SDR is a tool that gives us the ability to do both. And so here's another question. Could you pick one particular frequency, let's say 660 nanometers of wavelength? Could you pick one particular color and modulate its intensity? What do you think? You think you could take it and make it brighter and dimmer?
Would hope so.
Okay. Do you think you could change its frequency slightly?
Not really.
Up and down. Yeah, you could.
With a crystal or something.
You could.
Sure.
Yeah, you could. You could. Could you? Let's see. What other things can you do with it? Could you turn it on and off?
Absolutely.
Okay. So that being said, could you send audio with a laser?
Yes. Absolutely.
100%.
Could you send data with a laser?
Yes.
Yeah. And in fact, that's what we do all the time. It's called fiber optics.
And I think Elon does it across his satellites, if I'm not mistaken.
That's true.
Yeah.
So one of the simplest experiments that I've ever seen done, which is really cool, is to take a little handheld laser pointer and a solar cell, which is a little photoelectric cell, and connect that to a speaker, take the laser and hook up a microphone in series with the battery so that when you talk into it, it generates a very slight change in voltage, which changes the laser, point it at the solar cell, and your voice comes out on the other end.
That's cool.
I've heard you can do that to point the laser at a window and listen to sound signals
In
inside.
theory, yeah. In theory, you can. You're
Not that
basically
you've
picking up
done
the
it, not that
vibration.
you've done it, but
I've never done
No,
it.
no, no, only in video games.
yeah.
But supposedly
Asking
it
for a
does work.
friend.
Yeah. Okay.
There used to be a toy
Yeah.
growing up that did that. It looked like a handheld flashlight that was a beam of light. Two people had it and you could talk to each other.
Yep.
That's cool. That's the advanced tin cans and a string.
Essentially, that's just modulating. Modulation is the act of putting information onto a carrier frequency.
That was over 60 years ago.
Yep.
Yeah.
Hey, it worked back then. It still works.
Yep.
God, can I ask a question?
Yeah.
So I was looking at the band plan again earlier, and there's some bands that allow RTTY/data.
Yep.
So two questions. What does RTTY mean?
Radio teletype.
Okay, and what's an example of an operation that would involve RTTY?
Radio teletype.
Okay.
Computer to computer typing.
And then data. So I assume data means pretty much every form of modulation we've seen, DSM or packet.
Yeah, any form of digital communications.
Okay, so basically the world is phone and data.
Phone data and Morse code.
And CW. Okay,
right.
Thanks.
Which is
Wouldn't it be cool to have a pair? Sorry, go ahead.
No, go ahead.
I was just thinking, wouldn't it be cool to have a pair of goggles? You just look up into the sky and see everything's actually traveling around right now.
No, because it'd be blinding. If we could see radio waves, it would be blinding.
Well, yeah.
Let's see. Okay. A way to enable quick access to a frequency. You store it in a memory channel. A scanner is a radio that is designed to check a bunch of frequencies very, very quickly. Squelch. Okay, so squelch. So now we're looking at how a receiver actually works. So squelch, does everyone like listening to static? Raise your hand if you actually like listening to. I like listening to static because I hear things in the static sometimes. So squelch turns off the receiver when there's nothing to listen to. So if you're listening for a weak signal, you turn the squelch completely off so that you can hear that weak signal, because it might be that the weak signal is not loud enough to break the squelch, as it's called. Okay, repeater offset. So now we're talking about how repeaters are built. And okay, so here's my handheld radio, a very well-drawn handheld radio. And here's a repeater up here on a mountaintop. There's tower, there's a repeater. Okay, so the published frequency is 146.72 megahertz. That is the published repeater frequency. It is transmitting.
That's just a frequency you pulled out of the air.
No, that's actually the repeater that I'm the trustee for.
Okay, so you're using.
I'm using that as an example. Okay, so that is the published frequency. If you want to hear what the repeater is doing, you listen on that frequency.
Mm-hmm.
Now, in order to be heard by the repeater, there is something called an offset. The offset on the 2-meter band, this is the 2-meter band, is negative 600 kilohertz for this particular repeater. On another one, it could be positive. On this particular one, it's negative. So your transmitted signal, when I change the color right here, is 146.72 minus 0.600 equals 146.12 megahertz. So my signal is separated by 600 kilohertz. What the repeater hears is then retransmitted on its own frequency,
which is 146.72.
Right. Other people could be using a handheld and do the same thing, which is how multiple people have a conversation through a repeater. And because the repeater is on such a high spot, everybody who is in line of sight to that repeater can have the same conversation and have a big group talk.
Can you give us that again? I have got a somewhat understanding of what you said. You're
Okay,
the
so let's
keeper
okay,
that
so let's talk over each other. Ready? 1, 2, 3. Meredith,
we're
say your
gonna
name.
talk over
No, no.
each other
Yeah.
and
1, 2, 3.
everybody's talking
Yeah,
and
say your name 3 times. Ready? 1, 2, 3.
Meredith,
Scott, Scott,
Meredith.
Scott. Right? Okay, so that didn't work very well, right? Okay, so what a repeater does is it just like in order to keep the peace, what it does is it listens on one frequency and retransmits on another frequency. That way, the person who's talking, let's say this person over here on the left, is talking on a different frequency, 146.12, than the repeater is talking on. The repeater is just basically listening for people to come in on 146.12 and retransmit to the world on 146.72. And when you look up repeaters in your local area, you will see that they are listed by the repeater transmit frequency. And it will also specify for that repeater an offset of negative 600 kilohertz, which means that when you are setting up your radio, you need to know to change your offset, to set your offset so that you are transmitting 600 kilohertz below, which is 146.12 megahertz, so that you are able to access the repeater. Now, there's also something called a CTC-SS tone, which is between 67 and 254 hertz, which is a subaudible, low frequency tone that you have to sometimes transmit. This is another setup in order for your signal to be accepted. There's also something called the digital code squelch sometimes, which is, for instance, D023, which is a sequence of signals that are sent along with your signal so that your radio is accepted, that the audio is accepted by the repeater and retransmitted.
So it's like a sidewalk. You walk up, but you don't have a key, right? You walked up the right sidewalk, but you didn't have a key to get in.
Right. So you have an offset, a CTC-SS, and a DCS. So you basically have the frequency, that determines the frequency, and then you have one key and potentially a second key to set. These were done largely because a lot of this stuff was developed in Southern California. And in Southern California, there are a lot, if you look at what LA looks like, the LA basin kind of looks like this. And it's ringed by mountains. So you have repeater, 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 repeater,
So it helps
repeater.
specify which repeater you're actually talking to.
And they ran out of repeater frequencies. So Motorola came up with a scheme that said, we're going to put this one on 100.0 tone. We're going to put this one on 67.0 tone. We're going to put this on 254.0 tone.
Even though their receive
On
frequency
the same frequency, that's like an extra key that's thrown in to keep, because if all the repeaters that are on the same frequency were to receive and then retransmit at the same time, FM does not work very well with that. If there's more than one signal, nobody gets heard. So that was their way. That was their way of solving that problem.
Yeah, which essentially means that the repeater will only open up if that tone is in the frequency
Correct.
for that repeater site.
Right.
Yeah.
Now,
So-
if two different people are using two different frequencies or two different tones on two different repeaters, you'll still have a problem. But it greatly limits the possibility of that happening.
So how does that work from a real world perspective? The bandwidth that because I'm transmitting on one frequency, I'm listening on a slightly different. Is it the bandwidth is large enough that I'm listening to that it doesn't matter that I'm tuned slightly off?
Yes. Now, it gets really challenging. It's not a big deal for your handheld. Your handheld changes. Once it's transmitting, it's not listening anymore. The repeater, on the other hand, is simultaneously doing both. And when you're building a repeater, that becomes a big challenge. Then you have to start dealing with a way to attenuate one signal so that it doesn't get back into the receive signal.
Okay, but just mechanics of it. I've got my handheld. I'm actually typing in this offset. When I hit the button, it's transmitting on that. When I release the button, it goes back to the original frequency.
Yes.
Okay.
So
In fact, when
now,
you key it up, you'll see it change. Most
Yeah.
radios, you'll see that frequency that's on the screen, it'll change. It'll jump to the other one.
okay, so does everybody see this picture right here?
Yeah, there we go. Yeah.
Okay. That is a pair of receiver canisters or filter canisters that are called cavity filters. There are band pass, band reject, low pass, high pass, with the intent of taking two frequencies that are very close together and filtering one from the other so that so that the repeater's transmitted frequency does not interfere with its received frequency. If it does, what you end up with is the sound of a repeater getting locked up and it doesn't work anymore. So essentially, this is a very, very, very narrow filter for protecting the repeater receiver from its own transmitter because they're in the same place. Sometimes they even use the same antenna. And what's interesting about that is that it simplifies development and construction. The problem is, of course, that those are very finely tuned and they're very finely manufactured. And this is why a repeater is not cheap. You have a receiver and a transmitter and a controller to essentially mitigate or to control whether or not a signal is passed from the receiver to the transmitter. And then you have this massive set of filters. That set of filters can cost $4,000 or $5,000. And then it has to be very, very carefully tuned. So it requires somebody with very expensive equipment to go and set it up. That's why repeaters
And
are expensive to build.
How does a repeater deal with getting multiple users sending stuff on the same frequency?
If they're sending them if they're all talking at different times, everything's fine.
If they're talking at the same time, though.
If they're talking at the same time, nobody hears anything.
Okay.
It's just, and that's if you listen, that's called a double. And basically you'll hear that's what it sounds like.
What does a trustee do?
Nothing. The trustee is the person who's responsible for proper operation. And if something goes wrong, you get the nasty email. That would be me. Yeah.
Why is the offset on 70 centimeters so much bigger than the offset on 2 meters?
Because it can be.
Because it's such a big band.
Because it's such a big band. It can be. So it should be. Because the further apart those frequencies are, the less effective your filtering has to be.
But doesn't it also, I thought it was in reverse in terms of the offset, because when you look at like 70 centimeter, for instance, it could be like a 5 megahertz offset, right?
Right.
So is that because now you've got more bandwidth to play with as well?
Yes.
Like when you look at that chart you had, we've got a lot more room there, right?
Yes, absolutely.
Okay.
You're basically taking advantage of what's given. So if you can separate them by that much, then you should, because there's the end result is that it costs less to build a repeater. The filters are less expensive. And when we're talking about isolation of the receiver and the transmitter, we're not talking like 10 dB or 20 dB. We're talking like 110 dB. So 10 to the minus 10th power, 10 to the minus 10th. So 100 billionths of the transmitted signal is allowed to get back in.
Wow.
No, 100 trillionths. I mean, the filters are incredibly, incredibly tight because they have to be. So how about a 5-minute break, everyone?
Okay.
Thank
A lot of general and class information.
Hello.
Eighty ports on 20.
Okay, everybody, welcome back. That's better. Everybody ready to go again?
Okay.
If you've got questions, go ahead and ask. All right, here we go. Okay, repeater offset we just did, how a repeater works. Function performed with a transceiver and a digital mode hotspot. Okay, digital voice and data systems. There's something called voice over internet protocol. We actually do that. We have something called Echolink, which I use, which is a thing on my phone and on my computer where I have registered myself and I'm able to check into repeaters and all other kinds of stuff. It's an interesting way of being able to access a local repeater when you're not local to it. I do that a lot when I'm traveling. I get to talk with my friends and my family back home. A talk group or digital repeat is on a digital repeater. The difference between digital and analog is that digital is ones and zeros, whereas analog is analog. It's voice levels and things like that. If it's digital, then two digital data streams can be mixed together. You program your radio with the group's ID or code, and it allows you to use a half of a repeater, basically. A DMR code plug. DMR is digital mobile radio. A code plug is how the radio is supposed to work, where to find everybody that you want to talk to. That's called a code plug. If you happen to be going to Seaside and you have a digital mobile handheld radio, then there's a very, very crowded but very popular seminar on how to program your DMR handheld. Digital voice transceiver, you enter the group's identification code. Again, digital mobile radio. There's also something called a color code. A color code is a way of setting up your radio to access just individual DMR systems, because digital mobile radio is a hybrid between radio and the internet. And because it's a hybridization between the radio and the internet, everybody who has set up their radios to talk over the internet can talk with each other using the internet to radio links. So let's say that I have a friend who's on a handheld radio in Argentina. He's on DMR. I can dial him up if he's within sight of a DMR repeater, and it will cause his radio to become active. So one of the things in order to do that, you have to match the repeater color code to access it.
So is that kind of like a unique identifier for the station?
Yep. And most of the DMR handhelds now that you can buy have over 200, like the last one, I have one that has like 150,000 different addresses to program. And you can download the files from online. And some of the newer ones are over 200,000 unique addresses for DMR users. D-Star is another competing mode to DMR. There's also another one called Yaesu Fusion. If you're using D-Star, you have to actually sign in using your call sign, because it gets sent in the digital information and pops up on the other user's screen. Essentially, a lot of these DMR handhelds are basically a computer with a radio attached to it. Kind of cool.
For the color, someone manages the IDs?
Yeah.
Okay.
Hey, Scott, for Fusion versus D-Star,
it's like Betamax versus
right,
VHS.
Right, but so I was confused, I think, because D-Star, it does require your call sign to sign in.
Yeah.
Are you saying that Fusion you don't necessarily
probably does
need that?
also. Fusion probably does also. So
Okay.
D-Star is an ICOM and Kenwood thing, and
Okay.
Fusion is a Yaesu thing.
Yeah. Hence
So-
Sony and VHS.
Have Sony, yeah, exactly.
Yeah. Okay.
Okay, multiple receive bandwidths on a multi-mode transceiver. So we're talking about going to our software-defined receiver, which I hope is still open. It is. Look at that. Okay, so we're going to cover the concept a little bit of sensitivity and selectivity and things like that. So sensitivity. Did anyone hear that?
No.
Could anyone
Your
hear
mute's
that?
on. Your mute's on.
I don't think it is. Is it?
I see a checkbox there that says mute's checked.
Oh, no, that's just on the receiver. Does
Okay.
anyone hear what I'm saying? Ready? 1, 2, 3, 4, 5.
I heard
Yeah.
it.
Okay.
I heard it.
So
Oh,
that
I
is the definition of sensitivity. If you could hear the first time I said it, which was 1, 2, 3, 4, 5, your ears and your receiver were more sensitive. So this is selectivity. I have this set up right now to not be selective at all. Notice that you're hearing everybody under the sun. This is selectivity. That is the definition of high selectivity. It's the ability to ignore a lot of things that you don't want to hear while allowing just the thing that you do want to hear. And if I were to listen on, for instance, a single sideband signal, see if I can find one that's loud enough to hear. What I would hear is something that sounded like, hopefully, this. Come on. Okay, there's a good one. Maybe. Okay. So this is an appropriate bandwidth with the right selectivity for single sideband. Now I'm going to set this to the same bandwidth that I was using for Morse code. And why is it that we can't understand it?
Because you're only grabbing a piece of it.
You're only grabbing a piece of all the information. That whole bandwidth is used to convey all the information. Now, why is that much bandwidth necessary for us to hear a voice?
This voice is 20 kilohertz wide or so.
It's about 3 kilohertz wide.
Oh,
and what's important to note is that how fast are we talking? A couple hundred words a minute, typically. We speak, we convey a lot of information in our voice. Information requires bandwidth. The more information you have, the wider the space is necessary to convey it. If I take a look at a Morse code signal, it's just basically on and off, and you will see right here, for instance, 348. And that is not 200 words a minute. That's about 35 words a minute. And it takes a lot less space. So it's a fundamental fact that was discovered or theorized by Claude Shannon in the 1940s that information requires bandwidth in order to send it. The more information you have, the bigger the bandwidth it takes to send it. Therefore, if you're looking at a signal which has more information, you cannot filter it down too far, because if you filter it down too far, you're going to miss a big part of it. So, appropriate filter for single sideband, a narrow filter would be 2400 hertz. For Morse code, it's on the order of 250 or 500 hertz. A way to tune something in a little bit better, if you're off frequency, if you've never heard what single sideband sounds like, if you're off frequency, it sounds like this. Let me go back to it. All right, so we're going to find a single sideband signal. That's what happens if it's too narrow. And now we're going to make it wide. We're going to capture all the information. And now we're going to mistune it slightly. So really, we needed to tune this better, and we did a bad job. So let's say that that's the frequency we're on, and the other station can hear us just fine. Receiver incremental tuning allows us to tune just the receiver without changing the transmit frequency. And that's called receiver incremental tuning, or RIT. Okay. Push to talk is PTT. Again, push to talk. When the signal is grounded, it switches the transceiver from receive to transmit. Okay, station equipment, a transceiver. That is a portmanteau of the words transmitter and receiver. It used to be that the transmitter and receiver were in separate boxes, and you would have to throw a switch to go from one to the other. Now they're done automatically, and they're in the same box, which is nice because their frequencies track each other. A transverter is a device that transfers, or it's a transmitter that transfers its frequencies to another band through a converter. So that's called a transverter.
And you could call a relay a transverter?
No. I mean, literally, it switches from one band to another. The way that it works is it looks something like this. We're going to cover, this is a device, come on, called a mixer. A mixer is a combiner that takes one signal, whatever that one is, and another signal, and generates sums and differences. of those two. So if I had, let's say, 10 megahertz coming in over here and 8 megahertz over here, I would end up with 10 and 8, the original ones, and then 18 and 2, and 2 times 1 and 2 times another, and I would have 2 times 1 minus the other, so I'd have 12, and I'd have a whole bunch of frequencies coming through. Let's say that I was looking for 18 megahertz. I wanted to convert my 10 megahertz band radio to an 18 megahertz band radio. I could use an 8 megahertz intentional oscillator that I built and run it through this thing called a mixer and generate a completely new frequency. So if I were to now to look at this, what I would find is that here's a picture of all the frequencies that are now coming out of that thing. So here's 0, and here's, let's say, infinity. Here would be all the frequencies. And this one is the 18 megahertz signal. What would I do to capture that?
Filter it.
Filter it. I would use inductors and capacitors, and I would do this. I would build a filter that was resonant more or less at 18 megahertz that would eliminate all this stuff on both sides. And I would just be able to trap that one signal that I wanted. Thus, the beauty of filtering and tunable circuits.
Just to be clear, so the 10 megahertz on the left would, in this example, would most likely be a signal you're receiving, like someone talking, for instance.
That would be to the radio.
Yep. And then you're oscillating that 8 megahertz into the mixer.
This is called a local oscillator.
Okay.
And
so you're just sending that signal in at 8 megahertz, and then the mixer's doing its happiness inside there.
It's doing its non-linear thing.
Yeah.
It's a non-linear device. What's cool is that because it does sums and differences, I can also reverse it and put 18 in and mix it with 8. And what do I get out? I can get 10 back out. So when I switch from receive to transmit, I just have to reverse the direction of the mixer.
So this is because my radio doesn't have the right
radio
band?
doesn't have the right band. And in fact, if we now look at the different bands that we are allowed to use, for instance, you will see that one of the bands that's on here, that's not it. There it is. One of the bands that's on here is this 1.25 meter band, which goes from 222 to 225 plus another little section down below. The weird thing about I have no idea what that is. So the thing about this band is that this is not a ham. So the fact that this band is not a ham radio band in Japan, nor is this band. Therefore, since the Japanese have been very proficient at building equipment for many years, you will find that gear for the 33 centimeter band and for the 1.25 meter band is very uncommon. But we have access there. So in order to get radios that work on those frequencies, we will typically use a transverter to take, let's say, a 2-meter radio or a 10-meter radio, which we have lots of, and do a conversion and put them on those other bands.
Is that what a crossband does? And like when you do a crossband repeat in your radio and you set it to crossband mode?
Crossband, I mean, no, that's usually two separate radios in one box. And
Okay.
there's a device, there's a controller inside that moves the audio. This
Okay.
is actually changing the RF frequency.
Okay. Got it. Got it.
Okay. Let's see. There we go. What device increases the transmitted output power from a transceiver? That'd be a power amplifier. Some power amplifiers have mode switches, SSB, CW, or FM on a VHF power amplifier. And what I'm going to do is discuss this very briefly in terms of a transistor. Does everybody remember what a transistor looked like from yesterday? Remember a long time ago yesterday?
Got a base, collector, and emitter.
It looks like this. eventually. It looks like this. So that's a transmitter. Or sorry, that's an amplifier or a transistor. And we're going to decide how to use this. And this has a transfer function from input to output that looks like this. Remember those three sections right there?
Yep.
So this is cutoff, saturation, and the linear range in the middle. So because input and output are essentially linearly related in that interior section, that gives us the ability to use it as a linear amplifier. So what I would say is, let's say that my voice has a waveform that looks like this. And if you made it 3 times as big, it should look proportional to the original in every way. Well, this linear portion is great for SSB. But if I had a signal that just looked like this in time, where it was either on or off, like this. Does it matter how much bigger one is or one part of it is than another?
Yes.
No, not really. I mean, I just make it 3 times bigger. And if it's a little bit shorter, it doesn't really matter. So and this would be what we do for FM and for CW, which is Morse code. FM in time would just basically look like the same. FM uses something called uses something called a limiter when it's looking to demodulate a signal. And what ends up happening is that it doesn't really matter whether or not it's linear. So for single sideband, if it's not linear, it'll sound all distorted. For FM and CW, you can use these modes. And in those ranges, your amplifier is actually more efficient than in the middle. The reason being that you're basically looking for a center point. So you have to say, if I go this way from the center point, plus and minus around a 0 point, that means my signal is going to change linearly. The question is now, where's my 0 point? This is my 0 point, which means that when there's no signal there, I'm actually still transmitting something. I'm using up power just to keep the thing lit. Has anyone ever heard of a Class A amplifier?
Yep.
Like if you play music, if you have an audiophile amp, anyone?
Yep.
Not efficient, but it sounds really good, right? This is what people like to use, but it's not efficient. This is the same problem that we get with single sideband, and that's why there are multiple different modes. The higher the letter you go, so there's a class AB, there's a class B, a class C, class D, class E. They become less and less linear, but to a certain point, you don't care anymore, depending on the signal that you're amplifying. Okay. Selectivity and sensitivity we covered. Okay, an RF preamplifier. Has anybody ever dealt with communication systems like cable TV and stuff like that? Anyone ever had a cable TV where your a system where for some reason your signal was all like choppy and blocky?
Yes.
Video
Yeah.
teleconference. Yeah.
You hate that, don't you? Isn't that awful?
Mhm.
So let's ask a question. What we're going to do is we're going to talk about system design because that's really what this is about now. So let's say that I have an antenna. It could be a cable TV system. It could be anything. I have an antenna that's pointed this way at some kind of signal out here in the world. And I am trying to receive this signal down here in my box. And the signal, by the time it gets to my antenna, has a received signal strength of minus 120 dBm. Here we are back in dBs, right? Okay, we have cable loss. That gives me an extra minus 10 dB. So down here, we have minus 130 dBm, which is a power level available to us because we lost another 10 dB. And now we have a problem. The problem is our receiver is only good to signals of minus 122 dBm. So what's our problem now?
You got a deficit.
This is the sensitivity of our receiver. Will we be able to hear anything?
No.
Nope, we don't hear anything. Okay, so let's say we put an amplifier right here. And the amp is good for 10 dB. And it has a noise, it has a sensitivity of minus 125 dBm. What will this
do us any good?
It does nothing. The reason is that down here, our signal strength is minus 130, which means that the amplifier will actually not be able to even hear anything, which basically means that that amp does no good. It just amplifies the noise and makes it louder. So, okay, so that would not be a good place to put our amplifier. Where's a better place to put the amplifier?
Up next to the antenna.
Upstairs on top of the antenna, like way up here, because this is good to a sensitivity of minus 125 dBm, and it has a gain of 10 dB. So as it comes through, here's our amplifier. We now have a signal strength of minus 110 dBm. We lose another 10 in the cable, and we now have minus 120. Whoops. We now have minus 120. And all of a sudden, that is now above our sensitivity floor. And guess what? We can hear. We can hear our signal. This is why it's important to understand how to build a system that will work properly. The difference is that you take your preamplifier and you put it outside. Okay, so what are the challenges of putting an amplifier outside?
Water.
What else?
Dirt.
Cold.
Power.
Heat. Power. Wind.
Yes.
Yeah, all kinds of stuff.
Strikes.
So that's got to be, yeah. So that amplifier has to be really well protected, and you have to deliver power to it. But this is how a cable TV system works, except that instead of the signal coming in over the air through here, it comes in through a cable. So instead of an antenna, you have this little box here that receives a signal from another box through a cable. And it's the same thing. Right here, that's where the preamp goes for your section of cable so that you can receive a signal on your box.
Is that out in that little green box typically sitting out there? That's where they
can put it. Yep. Now, what if they don't have, or they put that in there and it turns out that you're still not receiving a signal? It might turn out that, let's say, this cable got compromised and its loss is now minus 20 dB. Then what does somebody end up doing? Find the damage in the cable, pull out the cable, replace it, repair it. I mean, this is all like, where this stuff meets the real world. This is the fact that we want to be able to communicate with each other. This is how the hardware actually has to work.
And they could be lazy and put a box that has better right at the top.
Yeah.
To overcome.
They could.
Yeah.
It's all about cost at that point.
So that I can actually put in my splitter, which is 3 dB loss per leg.
Yes, that's right. And also,
Scott,
yes.
I'm sorry, I didn't mean to interrupt you, but what was the M in the dBm? Maybe you said this, I didn't catch.
dBm is reference to 1 milliwatt. It's a reference to a power level. And sensitivity is usually it's usually talked about in dBm.
Is
for that
M
result.
capital or lowercase?
Lowercase. Okay.
And is dBm decibels per meter? Is that
No,
what?
no, it's decibels compared to 1 milliwatt.
Okay.
So
So
if
would
I
the M
have,
be like a subscript?
Hmm?
Would the M be like in a subscript
no,
if you type it up? No? Oh, okay.
here, so let's say here, let's say that something has a signal strength of 60 dBm. Okay, so we go back to our power calculator or our description of power, and it's 10 log base 10 of x, right? So this is 10 to the sixth power compared to a milliwatt. It's 10 to the sixth times bigger than a milliwatt. Okay, so what's 10 to the sixth power?
Um,
1,000,000. One with 6 zeros.
Yep.
Compared to a milliwatt is 0.001 watts. Multiply that. So 60 dBm is 1,000 watts. I could also, because of the incredible use of logarithms, I could say minus 60 dBm. So that is 1,000,000th the power level of a milliwatt. So that's 10 to the minus sixth, which is 0.000001, compared to a milliwatt, which is 0.001 watt, is 0.000000001 watt, or 10 to the minus ninth watts, or 1 nanowatt. These are like really achievable signal levels. I mean, you can have a signal that is minus 125 dBm, minus 130 dBm. I mean,
All right, so I've Googled dBm versus dBi, and I still don't understand where I'd use one versus the other.
dBi is a comparison. Well, that's totally different. dBi is,
or maybe all three: dB versus dBm versus dBi.
dBi is gain compared to an isotropic radiator. An isotropic radiator is an imaginary antenna that has the same gain in every direction in a sphere, which does not exist. That does not exist. It's a theoretical thing. There's also dBd, which is gain compared to dipole radiator, which does exist. This is a dipole. That's the pattern compared to a dipole. In other words, how much better is it than a dipole? Those are both comparisons to antennas.
And then if it's just general signal that we're talking about,
well,
inside of a system, once it's inside the system, then it's
dB is gain or loss compared to something. It's generic. But then dBm is signal strength compared to 1 milliwatt. And this is used as a reference power level of something, because it's already being compared to a milliwatt, which is power level. So it's the gain or loss compared to a milliwatt, which is already power. Therefore, this is power. It's a special case use of but very commonly used case of how to talk about power. And since dBs are dBs are dBs, you know, dBi, dBd, dB, dBm, you can combine them all because they're based on the same numeric system, which makes it very easy to work with them.
Thank you.
Does that make sense?
Yes, thank you.
Okay, good. Okay. The act of combining speech with an RF carrier signal, which is a radio frequency signal, is known as modulation. Taking that signal back out, what do you think that would be called?
Demodulation.
Okay, if you combine the words modulation and demodulation, what do you get?
Modem.
You get MODEM, which is a modem. Yep, it's a modulator demodulator. Okay, symptoms, causes, and cures for common transmitter and receiver problems. Radio frequency interference can be caused by fundamental overload. Let's say I have a receiver and I'm driving past WJOK. I did not make that up. It was all comedy all the time where I was growing up. Whenever I drove past that radio station, it didn't matter where I was tuned. I would hear that station. That is fundamental overload. The receiver simply has no choice. It has nothing. It can't listen to anything else. Harmonics are multiples. They're integer multiples of a frequency. So if I'm transmitting a signal on 10 megahertz, I would also be transmitting a signal potentially on 20 and 30 and 40 and 50 and 60 and 70, all the way up to infinity. One of the keys of designing a piece of equipment is that if you are building a radio, there are specifications of how much attenuation you need of harmonics based on the number of the harmonic in decibels down. In other words, the attenuation down from how big your original signal is. And it's a ratio. Depending on the frequency you're on, it's either 40 or 45 or 50 or 55 or 60 decibels lower than the transmitted signal. And then there's a spurious emission. I had a radio that did spurious emissions recently. It was getting old and the amplifier was no longer neutralized very well. So what would happen was that inside the amplifier, there would be a frequency that was generated because now I had a resonant circuit and it was on no particular frequency that I wanted it to be. That's called a spurious emission.
I don't understand. Is that comes out as noise? That
it comes out as a different radio frequency that you did not plan on. Because what makes a resonant circuit? Two things are needed to make a resonant circuit.
Resistance and capacitance.
Not a resistor, a capacitor and
inductor.
And there are plenty of things inside a piece of equipment. Every wire is an inductor. And any two wires that are separated by a distance are what?
Capacitor.
A capacitor. You take that inductance and that capacitance, and if you are not lucky, what will happen is they will oscillate with each other if you have energy flowing into it, and they will start to oscillate. And if that's in a transmitter circuit, you will start to oscillate and generate radio frequency energy at some frequency that you never planned on making.
So it could be a defect in the circuit system, just in insufficient shielding, maybe?
Yeah. It could also be that something in there started to decay. Like for instance, capacitors don't last forever, they dry out. It could be that it was a tube amplifier and the tube has capacitance built into it because of how it's built. It has two plates separated by a distance. That's a capacitor. It has intra-element capacitance, and you actually have to go through and neutralize your amplifier to eliminate the effects of that capacitance. Otherwise, it will start resonating. It will become a resonant circuit and it will generate its own frequency and amplify those frequencies.
just quick, can we jump to option A, back to your joke channel?
Yeah.
So what was the, who, I hate to put it in these terms, but I can't think of any, who's at fault, or how do you correct that situation?
It's my crappy receiver in my car.
Okay,
Yeah.
so not overpowering overload.
No, they're a station that is licensed and is operating within its operating parameters and is working correctly is never at fault.
Okay.
That is important to remember. If your station is licensed and you can prove that everything is operating the way it's supposed to, you are covered by your license, which is under Part 97 of the FCC rules, which says this is an amateur radio station. If somebody else gets interfered with and they are not a licensed service, for instance, it's a TV or a radio or a cell phone or something or a computer, if you look on the underside of every electronic device, you will see that it is a Part 15 device. Part 15 is an unintentional radiator, which can radiate signals. If that causes you interference and you have a license, like a ham, you can actually tell them, the owner of that equipment, that they need to shut it off because it's causing you interference. If when you transmit with your radio, it causes your LED light strip to start blinking as you speak, that's not your fault. You might be able to help, but that's not your fault. That means that that other device was built badly. It wasn't engineered properly. And maybe it can be fixed. What would you possibly do to fix it? You'd put a what on it?
Ferrite choke.
A ferrite choke, exactly. These things
Or I
become
build
your
a
friends.
Faraday cage around it.
Or you could, yep. I mean, but what if it's in your own home? My kid has a set of LED string lights in his room, and it's it's modulated somehow. And when he turns it on, I get spurious. I get every 10 kilohertz, I get a little spike on my radio. It doesn't take much. I mean, it's probably microwatts, picowatts even, you know, but I can still hear it, and it causes me interference. So when when he turns his lights on, I know that he turned his lights on. And if I'm trying to do something, I'll say, Nate, turn the lights off.
I have a clothes dryer that has a buzzer when it reaches the end of drying cycle,
Mm-hmm.
and that will blank my LCD TV every time it goes.
Wow, really?
Yeah.
Yeah, it
Really
generates it's called RFI, which is radio frequency interference. I whenever I used to transmit my parents' stereo, I would say even if it was turned off. The speaker wires were acting as antennas, and the speakers themselves were demodulating my signal, and they could hear me.
Wow.
Yep. So make sure your station is functioning properly and it doesn't cause interference to your own radio or television when tuned to the same channel. That's how you can prove that a neighbor's TV is at fault.
Oh, okay. Good. One follow-up question. Sorry to belabor it. Okay, so let's say that radio station WJOK.
Yep.
How
which does not exist anymore, by the way.
Oh, that's too bad, because I really wanted to go.
It was really funny. Yeah, I liked it.
Okay, so other than pointing to Part 97 paperwork licensing, how might they counter an assertion that they're causing the overload? I mean, is there any kind of test they can do and say, look,
they've got a radio station engineer who can certify those things. That's they can be fined just as badly as we can.
Okay, so if
for causing interference.
If we're in the same position, we can point to the license. Is that all we need to do, or is there some
well,
testing?
I mean, let's say that their station is actually generating spurious emissions, right? If it's something that was not intended, they probably want to know, because then if you can work with them and show that they're in violation of the FCC rules, they really want to know, because you just fix your thing. They're running a 50 kW transmitter.
Yeah,
they really want to know.
I guess I was thinking in terms of diagnostics and locating, which device are we transmitting the interference, or are you receiving the interference despite or clean transmission?
Usually you're being interfered with by something else. I mean, if you're the cause of interference and the other thing that's being interfered with is not a protected device, protected by license, then it's their fault unless your stuff is not working properly. So it's important to understand what working properly is. In some cases, that might mean I have access to a friend who's got a spectrum analyzer.
There we go.
There are a lot of hams who have spectrum analyzers. There are a lot of hams who are TV station engineers who have some access to some really expensive equipment who can help you out.
Okay. So that's
Um,
where it comes back to the language of this device must accept such interference.
Yes.
That's buried in there somewhere.
Yep. That's in part 15.
Okay.
First step in resolving non-fiber optic cable TV interference caused by your transmitter. Cable TV, those little F connectors that are provided can very, very frequently just wander loose. Don't know why. They just come loose. And then a system that isn't properly sealed for RF causes leakage to get out and leakage also to get in. So tighten all your connectors. What would cause a broadcast AM or FM radio to receive an amateur radio signal? Unable to reject strong signals outside the band. That was me and WJOK. Fundamental overload. There's a way to block that. If I really wanted to, I could build a filter and put it on my antenna so that when I drove by that radio station, it did not get through the filter. So filtering, ferrite chokes, they're kind of, ubiquitous in all of these things. Reducing overload of a VHF transceiver by a nearby commercial FM station. That's even closer to my WJOK application. A band reject filter, essentially rejecting that frequency band. That's also known as a notch filter. Because if you look at if the band pass, it's basically flat, except that a big chunk is taken out of it where it's blocked.
In that case, would you miss all the jokes when you drove? You'd miss
I
all the
would.
jokes forever, right?
I would, yeah. I'd have another receiver for it,
It'd be just the punch.
If something in your neighbor's home is causing you harmful interference, work with your neighbor, inform your neighbor that the FCC rules say and make sure your station is designed properly. I had a neighbor who I did not know at the time, but my wife did, who lived about a half a mile from here, who was transmitting her phone calls on the 80-meter band. It turned out she had a device that was it used the house wiring in her house to carry a modulated signal, which was basically her phone call, and put it out on another phone, which was a cordless phone that could be plugged into anywhere in the house that didn't have a phone jack, essentially using the house wiring as a connector. Okay, everyone, any piece of wire can work as what?
An antenna.
An antenna. This was operating on 3.522 megahertz. That is right in the 80-meter band. And that house wiring ran 50, 60 feet through her house until it got to a transformer, maybe 200 feet of house wiring. That's a 200-foot long piece of wire that is carrying 3.522 megahertz. And that is sending radio waves all around the neighborhood. So whenever she was on the phone, I could hear her talking, and it was on FM, which was really weird. And I went around the neighborhood with a little handheld portable radio, and I tracked it down. I said, "This is the house." And my wife said, "I know who lives there. I'll call her." And I was able to listen to their conversation. And she said, "Okay, well, I'm not going to use this anymore." She unplugged it and said, "Would you like it?" I said, "I would love this." And I gave it to our RFI, which is radio frequency interference person in my neighborhood, who's a ham who lives down the hill from me. And he said, "Yeah, these things are terrible. I remember when they came out. Boy, did they cause a lot of problems. I can't believe it was in there for so long."
When you heard her, did you hear both sides of the conversation?
Yes, I did.
I've heard that in telecom too.
Mm-hmm. Yeah. So, okay. If you receive a report that your audio signal through an FM repeater is unintelligible, you could be off frequency, you're in a bad location, in which case your signal is weak, or your batteries could be running low, in which case your signal is not deviating properly. The way that FM works, okay, so here is AM. An AM signal is always on one frequency more or less, and in time, you use your voice to do this with it. So this is the modulating signal, and you have a very, very, very high frequency carrier, as it's called, and you change the size of the carrier signal. And notice it's still a really high frequency, and it will be mirrored like this. So it'll have an envelope, which is above and below, and now you have shaped your carrier wave so that it looks like your voice, more or less. When it gets to the other end, you basically strip out the carrier wave and you just trap this signal, which is your voice. So that's how you demodulate that signal. FM is very, very different. FM is frequency modulation instead of amplitude modulation. Amplitude modulation changes the size of the signal. FM, if this is my center frequency that my radio is tuned to, the frequency that is modulating the signal will create a shift, plus and minus, around that frequency. So all of this, all the signals that are contained in this block basically are frequency representations of my voice. At that point, they then have an amplitude that is intentionally capped off. So all the information is contained in the frequency, not in the amplitude, so that when it goes out into the real world, what happens is when it gets to the other end, it maybe looks like this in amplitude. And let's say there was a static crash or something. What ends up happening on the other end is that there's some device called a limiter, which looks at the signal and knocks off everything above a certain level, which now looks very similar to the original signal that was sent in the first place. Also, if I take the signal and I make it uniformly bigger, that would be what static does, like a lightning strike, static crashes. Well, all the signals just got bigger. We're still capping it off. So that has no effect, which is why FM sounds really, really clean, because lightning, static crashes are amplitude modulated, and FM is something typically not found in nature, which is why it works so well.
In your example, since voice takes 3,000 hertz, that's the frequency plus or minus 1,500 hertz on each side? Or is it not linear? Well, it's linear, but
you typically have something called a modulation index, which creates deviation from a center frequency.
Yeah, I was just wondering how far off it deviated the frequency.
So an FM signal is usually plus or minus 5 kilohertz.
Thank you.
So you would have a modulation index that would be used to take your voice and shift it back and forth a certain distance. Now, if you have commercial FM, for instance, music, the more resolution you have, the better off you are, right? Because you can tell the difference between different frequencies really well. FM radio is plus or minus 100 kilohertz. And why do we do that?
Better fidelity.
Better fidelity. We want to be able to tell the difference very easily between two frequencies that are very close together, so we can tell, who's playing the guitar and who's playing the saxophone. We want the fidelity. And what do we give up in order to get that fidelity?
Channels. Less channels per.
It takes more bandwidth. More information, more fidelity takes more bandwidth because it just has more information. So, yep.
Hey, Scott, I got a
Yeah.
quick question around the audio piece of it for
Uh-huh.
frequency for FM. Um, I always thought like over here in Yakima, there's 107.3 as a
Uh-huh.
kid versus 94.5. And it
Yep.
seemed like 107.3 had better bass than 94.5. Is that just purely on their end?
Yes.
Okay.
That's going to be pre-emphasis on the audio side before it's
Okay.
before it's pumped into the FM modulator.
Okay. So it doesn't have anything to do with what frequency it's sitting at.
No.
Okay.
No, it actually can't. It's all, what how the baseband signal is modified before it's used.
Okay. All right.
Okay. RF feedback. If radio frequency gets into your transmitter or transceiver, you will sound distorted and garbled. Because there's something called a microphone gain on a lot of radios. Handheld radios don't have microphone gain. The way to achieve microphone gain is to basically do this. Can everybody hear that I got quieter? If I'm not loud enough, I can do this and put it right up next to my mouth. That is how you change the gain of the microphone. Using basic test instruments and soldering. A multimeter. Multimeter is good for voltage and resistance, sometimes current, but those are the two, voltage and resistance. A voltmeter measures electric potential or EMF. A voltmeter is connected to a component to apply voltage in parallel. You're basically looking to see how much voltage there is across the device, whether it be a battery or a resistor. One of the ways you can blow up a multimeter is by using the resistance setting to measure voltage. Because what is inside an ohm meter is a power supply, like a 9-volt battery, which puts a test voltage across a device, like a resistor, and measures using an ammeter how much current flows. And it does Ohm's law and tells you what the resistance was. Well, if there's another voltage source in there, it's basically going to run a ton of current potentially through that internal resistor or through that meter, and it will blow up your meter. There are lots of ways to blow up your meter. The most important thing to do is remember to hook the leads to the right place. And just make sure that the setting is on the right position. When measuring high voltages with a voltmeter. Okay, who here has a Harbor Freight nearby? Raise your hand. Yell it out if you have Harbor Freight nearby.
Yeah.
Nearby.
Yep.
Yep.
Does everybody
Yes.
love
Yeah.
does everyone love their Harbor Freight? I love
Yes.
having Harbor Freight nearby.
Used to. It used to be a bigger deal.
It has its place.
Yeah.
Okay. Agreed. It has its place.
definitely.
Semi-disposable tools of fair quality, right? Let's be honest. That's what it is.
Or anything
Okay.
without moving parts. Yeah.
Without moving parts. Yeah. Okay. So here's Harbor Freight. Notice sometimes they sell a multimeter. Sometimes they'll just give them away. Notice this is $7 for a multimeter, and it works. Okay, here is a Fluke Model 87, which is what I use for work. And notice my Fluke Model 87 costs $450, and it is a multimeter. It does the exact same thing as the Harbor Freight $7 multimeter. So what's the difference between these two multimeters?
Well, the
Fluke is rated for a lot higher voltages.
The Fluke is rated, well,
Accuracy.
in theory, that other one, the Harbor Freight one, says that you can use it. There's like a 750 volt setting. I would not do that.
No, I wouldn't trust that either.
Sensitivity.
Yeah, sensitivity, accuracy. I have a $7 multimeter because I throw it in my bag and I don't care if it disappears. I'll happily measure 24 volts with it. I'll occasionally, if I'm wearing gloves, I'll measure 110 volts in the wall socket to make sure it's okay.
It's good enough for many situations.
It's good enough for many situations. I take my Fluke on the road because I sometimes do have to measure 480 volts DC. And I do want to know if I'm at 22.7 or 22.9 volts DC. That to me is important. You know, the fluke is very unlikely to blow up in your hands, and the leads are rated for 1,000 volts, whereas I'm pretty sure that the Harbor Freight one is not. So, you know, every tool has its place. This is not an ad for Harbor Freight. Okay. How is an ohm meter connected to a component to measure its resistance? In parallel, you also want to disconnect the device being tested. Ensure the circuit is not powered. The easiest way to do that is to disconnect it. It might mean unsoldering one side of a resistor or something. Okay, so an ohm meter, as we said, has a battery in it, and it delivers a current and measures the current. If it is connected to a capacitor, the capacitor will charge up, but at first it will accept a lot of current, which is essentially a short circuit. It will look like 0 ohms. As it charges up, it will go to infinity. So when you charge it, when you measure the resistance of a circuit and it turns out there's a big capacitor in it, you will see that the resistance starts at 0 and goes to infinity. It looks really weird, but that's what's happening. To measure electric current, you use an ammeter, which is an amp meter. When configured to measure current, you put the meter in series because it has to experience all of the same current that the device that's being tested is experiencing. So that means that if you have a device that is expected to be carrying 20 amps, how much should your ammeter be capable of carrying?
More than 20 amps.
At least 20 amps. For really big currents, we don't do that because that's kind of a pain. And we actually use the fact that currents create magnetic fields, and we put a coil around the wire, and we use the induced current generated by the magnetic field to indirectly measure the current.
Amp clamp.
Yep, amp clamp. Inductive ammeter. We don't use acid core solder. It's kind of a backwards question, but we don't use acid core solder. That is used for other things, and it will destroy your circuit board. If you've done soldering and you get something that looks lumpy or rough when you're soldering, that means that it's a cold solder joint. Cold solder joints might be a good electrical connection for a little while. They will undoubtedly fail when you are least expecting them to in the most inconvenient manner possible. So a good solder joint is nice and smooth and shiny. Okay, FM operation. So we are in the home stretch, everybody. And how about a 5-minute break?
Sounds good.
All right.
Yes.
Okay, dokie, we're back, everyone. It's been 5 minutes. Everybody stretch. Seventh inning stretch.
Sure, it go by fast.
All right, everybody set? I see somebody's outside.
Yep.
Okay, here we
Yes.
go. What type of amateur station simultaneously retransmits the signal of another one on a different channel or channels? This is a repeater station. It can be a crossband repeater. It can be an in-band repeater. The key is that it's a repeater station, and it is a form of automatic operation. Types of amateur stations that can automatically retransmit signals. Repeater station, an auxiliary station. You might say, what is an auxiliary station? That could be a transmitter that's used to link two repeaters together. It's a single purpose thing that just retransmits from one to another. There's also something called a space station. Space is defined as anything 50 kilometers or higher in altitude. That becomes a space station. A linked repeater network is a network in which signals received by one repeater are retransmitted by all of them. These are very common in areas that, let's say, a network has been set up for emergency communications or for storm spotting. We have a repeater system in Oregon that covers all the way up into Washington, down into California, and east into Idaho and Nevada. And it has 50, I think at last count, 52, 53 repeaters all linked together. So if anybody can use any of them, they can use all of them simultaneously.
What's the name of that network?
Peak Radio Association.
Okay.
In the 2-meter band, the common repeater frequency offset is plus or minus 600 kilohertz, which we talked about. The 70 centimeter band, it's plus or minus 5 megahertz. You just got to memorize it. A subaudible tone, we talked about this. This is called CTCSS, or Continuous Tone Carrier Squelch System. If that's not set properly, nobody will hear you. The repeater will not accept your audio. There's another thing called DCS, which is digital coded squelch, which is similar to CTCSS, but different. The end result is the same. We'll sometimes say you're transmitting on the output frequency or your offset is wrong. If your offset is wrong, that means that you're not being able to be heard by the repeater. And I see Merida's hand raised. I didn't know I could see that.
I just have something missing. I just want to tell you my understanding of something, and you tell me where is the gap in my knowledge. So this is back, and this is a repeater thing, and it's back to what I have written down for what I the frequency thing and the offset thing. So say as an example,
Yep.
I understand the frequency is 146.72 megahertz.
Mm-hmm.
And I understand we're going to use 0600 kilohertz offset because we need to not coincide. And so we're going to be transmitting, and it says a tone can be an extra key / tone on a frequency.
Yep.
So we take a megahertz number and we just slightly tick down just a little teeny bit, and we get this other band wavelength number value. And so this -600, the different tone, the extra. One of the ones that's 146.72 it's all contained in the one airspace, but there's one carrying the set of dashes and not dash, one setting the signal that's what they're saying, and one is going to be carrying what they're listening to. But what is the mechanism that all this is in one enchilada, like in one wavelength? Like, what do you mean there's room for the two things with the extra tone hitchhiking along?
Okay. So here's the offset, right? That means that the receiver is listening 0.6 megahertz lower, because that's the same as 600 kilohertz, 0.6 megahertz. So this is on 146.12 megahertz, where you are transmitting, and other people who might be in a different place are listening on 146.72, and they're able to hear you. People take turns. When you key your radio, it changes frequency from 146.72 on receive to transmit on 146.12. That's a function that's done automatically. Now, so the repeater is basically taking the signal, and if I were to look at how a repeater is built, essentially this is a repeater. There's a controller and a transmitter. It's multiple separate boxes. The receiver hears everything that it's hearing. The controller receives the audio from the receiver and decides good or bad. So if the controller says it has to have a tone of 100.0 hertz that's been superimposed on your voice, and it's not there, it will select bad and it won't retransmit it. If it is there, it will select good and it will forward it on to the transmitter where it can be transmitted back out to the world. So think of it as a gate. Your signal has to contain all the elements that the controller will be happy receiving for the controller to decide that it makes it through. It's essentially the gatekeeper.
Mm-hmm.
Does that make sense?
Yeah.
Is the time required to do this infinitesimal?
I mean, it's in real time. It might
But
be,
the delay is just offset by 200 milliseconds or so, or
well, the audio delay, yeah, it's a couple 100
Speed of light.
milliseconds, 200 milliseconds. No, because it has to be dealt with internally.
That too.
in the controller.
Yeah.
To
Usually
Meredith's
that's,
question, oops, sorry.
go ahead.
I was going to say to Meredith's question though, that 100 hertz tone, I can hear 100 hertz.
Yeah,
What's
it's usually stripped out. It's usually then removed from the retransmitted signal.
okay?
Sometimes, however, it's not. Sometimes it will be sent on through.
Hey, Scott, I've got one quick question around squelching and tone squelch. One, I was talking with the guy here, he's like, I always leave mine on, just tell my radio on tone. So that way I can hear simplex radio to radio or not. And I did that, but what happened ended up happening was somebody was around here either had a low signal or whatever it is, but it was on that frequency. So I was hearing these spurious little, key ups and stuff.
When
I'm
it
like,
finally
I
got
hate
up to
that.
that point, yeah.
Yeah, so then I went back and I set it to T squelch. So am I correct in saying that when I set it to T squelch in general, that means that my radio is actually waiting for the tone back as well?
Yes.
Okay. All right.
Effectively, your radio is then set up similar to how the repeater is set up.
Okay.
It's
All right.
it's essentially looking for that signal in order to open the squelch in the first place.
Okay. And if it doesn't hear that, it's quiet, and that's why I don't hear those spurious key ups and stuff anymore.
Correct.
Okay. Okay. Thank you.
Yep. Okay, a reverse function on a handheld radio, for instance, that allows you to listen to the opposite frequency. So that would mean that if I'm listening to the repeater output frequency and I hit the reverse button, I would listen on the repeater input frequency. The reason to do that is because there might be somebody who is unable to hit the repeater, but is actually close to you that you could hear directly. When would you be distorted on voice peaks? If you are over deviating caused by over modulation of your signal, which means you're just talking too loud. How do you fix that on a handheld radio? You back away from the microphone. Okay, an appropriate way to call another station on a repeater. Does anyone else here have their license yet?
I've got my GRMS.
Okay, but anyone have a ham license yet? I thought there was one.
Thought so too.
I've got my technician.
Call sign?
Me?
Yeah.
KL4IZ.
Like
so Kilo Lima 4 India Zulu.
Okay, if I wanted to call you, I would just say KL4IZ N7JI. You identify the other station's call, and then you're on. If I wanted to say I was listening, I'd say November 7 Juliet India, listening or monitoring. That means I'm not there. I'm just listening on the frequency. If you're just talking back and forth on one frequency without a repeater, you are simplex. There are simplex channels set up in the VHF and UHF band plans because bandwidth and repeaters are both resources, and we want to be efficient with our resources. So therefore, let's say you and a friend are a quarter mile away, and the intent is not to bring other people into the conversation. It's just for you and that other person to talk. There is absolutely no reason, unless you really want to tie up the repeater and use that resource.
Scott, could I set my T squelch on both radios to the same?
Sure. Okay. So long as you transmitted the tone with both. Sure.
Yeah, and then that way no one else could hear it, right?
Oh no, they'd hear you.
Oh, they do?
Well, I mean, you're transmitting a signal. If they don't have T squelch turned on, they'll hear whatever's on the air. You won't hear anything else, but they will.
Oh, okay.
I've got an SDR set up that by default ignores the tones.
Mm-hmm.
And then
I typically don't use tone squelch on my handhelds.
What do you use?
I just leave it. I just turn the squelch up. If there's a signal there, I want to hear it.
Yeah. Okay.
The national simplex calling frequency is 146.52 megahertz. That's just memorization. Almost everybody listens and scans through that frequency. I know I do on every handheld, on every radio I have on the 2 meter band. Less common is the 70 centimeter calling frequency, which is 446,000. HF operations, CQ. We don't use CQ on a repeater. It's just poor operating practice because there's an intent that the repeater's there. If you're listening, you just throw out your call sign or listening. If you're on the high frequency bands and you're not using a repeater, you would say CQ. This is November 7, Juliet, India. It means I'm basically calling out into space and I'm looking for anybody. In Morse code, it's still CQ. In any mode, it's still CQ. Literally, like seek you.
The call sign requirements on that you give your call sign every X, is that just for automated?
No, everything. The rules are you have to identify with your call sign every 10 minutes and at the end of the communications.
Every 10 minutes and at
but
the end.
you
Okay.
don't have to at the beginning, oddly enough. Very strange.
Okay.
Yeah. And if you're in Canada, it's every 30 minutes. So that's why it's important to know if you're going for a license in another country, what the rules are. And if you're operating in Canada with a US license, which you're allowed to do, you need to know the Canadian rules and vice versa.
Is it 30 minutes because of the exchange rate?
Yeah,
good
kidding. Question. That's the way it's codified in the rules. Before calling CQ, you make sure you're allowed to be there frequency wise and transmit there. Then you listen to see if the frequency is in use, and then you ask if the frequency is in use because you don't know that the frequency is in use or not. It might be that somebody is there and you just can't hear them. They might be listening to somebody else that you also can't hear. So you transmit and you might be just basically obliterating somebody else. How do you respond to a CQ? CQ, CQ, CQ. You would just throw out their call sign and then your call sign. When performing a test, you still have to identify your station. You have to identify every signal that your station puts out in one form or another. Now, it used to be a long time ago. You got anybody who was licensed in the 1950s or 60s? No? Okay. So it used to be that you used to actually have to put in your logbook every time you keyed your transmitter for any purpose, for any duration. So if that meant I did a test transmission that was 5 seconds long, that had to go in the log. Your log could fill up very quickly. You don't have to do that anymore. You don't even have to log contacts. Most people do, but you don't have to. Okay, we also use Q signals, which are shorthand, most often for Morse code. Sometimes they're used for voice. QRM, we use that for voice as well. That means I'm receiving man-made interference from other stations. QRN is natural interference or natural noise. That's like static crashes. You don't hear that much on VHF or FM. You do hear that a lot on HF, especially on 80 meters during the summertime when you have a lot of thunderstorms. Static crashes are AM and they travel a very, very long distance, especially when there are, a couple thousand an hour happening. QSY means I'm changing frequency. A band plan. Okay, so this chart, which I showed you, right, if I can find it right there, this band plan, for the most part, the FCC really does not care. This is not in law. The FCC has said that the 17-meter band is from 18068 to 18168. The FCC has said that the 2-meter band covers 144 to 148. But how it is used beyond that is totally up to us. In order to keep the peace, there is something called a voluntary band plan, which is a guideline for making sure that different modes don't interfere with each other within a ham band. There are really only a couple of rules. One of the most important to follow is to understand where your signal is. So let's say that you tune your radio to 148.0. Would your signal be inside the band or outside the band? Is it legal or not?
Inside.
Any other competing ideas?
I think that's
yeah.
outside.
Yeah, but
Say it one more time. Could you say the
Let's say
question
you
one more?
tune. Let's say you tuned your radio and you start transmitting on 148.000.
you don't want to be on the edge because you could be off a little bit on your radio and transmitting out of the band.
Your dial
Well,
could
it
be
looks
off.
like
Yep.
it looks like the upper is at 146.52.
No.
40.
No. No, the band goes 146, 144.0 to 148.0. This is something you have to memorize as well. That's a 2 meter band.
So
So
what is that
because you're
indication on the band chart that you were looking at though? At the end of it, it says somewhere, it says 146.52.
Well, that says
What
calling
is that?
frequency. That's the calling
Oh,
frequency.
okay. I misread that.
So the band goes from 144.0 to 148.0. So again, if you set your radio to 148.0 and transmit there, are you legal or not?
No.
No.
Well,
Because
where
it's
you-
transmitting on both sides of the center point.
well, that depends, right? You could be if you
Something
had
else.
no bandwidth and your band, because what's the only rule that you really have to follow? All of your signal has to be inside the band. All of your signal has to be inside the band. Whatever that transmitted signal is, all of it has to be inside the band. So if you have no bandwidth, then you're okay. If you have any bandwidth that extends to the positive side, let's say your signal looks like this. You are out of band and you are in violation of the rules. If you are operating on lower sideband and your signal looks like that, there is a chance that your signal would be okay. Now, what if your radio were off by 1 kilohertz on frequency?
You're not legal anymore.
Yeah, if you think you're there, but you're actually here, then you're not legal anymore. So typically we try to stay away from band edges for that very reason.
Around the same sort of thing, but bandwidth sharing or frequency sharing. I want to set up a 100-watt amateur TV transmitter.
Lots of good things to look
Is
at
it-
on the way to the treehouse.
Oh, okay.
Is it just that?
Good. Yeah, we're that about a mile away.
Is it just that the signal's not going to carry that
Yeah,
far? That
I want.
I'm not interfering.
Hold on.
Yeah.
No.
There we go. Go ahead.
Okay. So I want to do a 100-watt amateur TV, but that's a high duty cycle type of thing, right?
Yeah.
Because I want to transmit a TV show for 30 minutes, and I'm going to do my call sign every 10 minutes or so, but I'm interfering with other people. They can't use that frequency during that time.
I'm not worried about that. I'm not worried about that.
Okay. So we just
honestly,
deal with.
Yeah, I mean, and that's basically, how much is that frequency used? If you live in an area where it's not heavily used, you probably don't want to transmit more than 10 minutes at a time. And, but there's like we have repeaters here where somebody will download the Amateur Radio Newsline, which is a news program, which is 20 minutes long. And they have an agreement with the owner of the repeater that, you ID every 9 minutes and you can use the 20 minutes to basically do bulletins. It's fine. I mean, how you use those, you don't want to monopolize, but if somebody says, I mean, that's not in the FCC rules.
I was
How
just
you
wondering
use
how we deal with it as amateurs. That
you just work it out.
Okay.
Okay, so that's a band plan. Which of the following applies when two stations on the same frequency interfere with each other? They negotiate use of it. I mean,
that was the answer.
nobody owns a frequency. That's the most important thing to remember. Nobody owns a frequency. ARES is the Amateur Radio Emergency Service. This is a group of licensed amateurs who have registered their qualifications and equipment for communications duty. I'm a member of ARES. I work with my local group. ARES is administered by the American Radio Relay League, or ARRL again. Another reason to join ARRL, because some of their operations go to work on the development of ARES. Essentially, ARES is an organization that is completely voluntary, and you, in case of emergency, you have a served agency that you work with, and the served agency will say, we need your help with communications. This is a little different from RACES, which is the Radio Amateur Civil Emergency Service. Notice it says civil. That means it has something to do with the government. And in fact, RACES is, instead of just registering with ARRL, you have actually registered with your local government that says that in times of emergency, they may activate RACES, and that they will actually perform, using amateur radio, a government emergency service. That could be crowd control, that could be delivery of supplies, things like that. Really, they do largely the same thing, but RACES is more governmentally directed and official. And it's also listed in Part 97, whereas ARES is not. So for anyone who didn't figure that out yet, Part 97 is the section of the FCC rules that govern amateur radio. Net control. So if we're running a net is short for network. A net control station is basically the person at the center of the network who does all the gatekeeping. So let's say that our net control station brings the net to order and says, okay, do we have any check-ins? And I'm actually going to ask, do we have any check-ins? Please come now with your name. Anyone?
Jason Souter, WSHB 471.
Okay, Jason, I've got you on the log. Please stand by. Anybody else would like to check in?
Mandel.
Okay, is it Joe?
Yeah, Joe.
Joe. Okay, Joe. Joe, thank you. I've got you checked in. Thank you for holding on. Anybody else would like to check in? Please come now.
Elisa.
Okay, Elisa, thank you very much. I've got you checked in. All right, so we're gonna hold check-ins right now. Do we have any traffic for the net? Please come now. Traffic is information of some importance to the function of the net.
So when you check in, you give your name and your call signal?
It usually depends on the net itself. Usually name, call sign, location, and some potentially power level, antenna. It could be any number of different things. It's based on the net control station, whatever they want from you, and they'll ask you to stand by. And then they'll start taking traffic. Say, do we have any traffic from any of the stations checked in? Please come now.
What you're talking about right now is specific to
the purpose of the net. You created a net for some reason. It could be practice, it could be testing equipment, it could be that there was a power outage. Do we have any, damage or a storm? Do we have any damage reports? Please come now.
Okay, but it's not specific to the RACES or the other one.
No, this is just how a net functions. Okay, nothing heard. Do we have any health and welfare traffic? Please come now. So that would be if anybody has any information for somebody else saying that they're okay, or somebody else handed you a piece of information saying that somebody is okay and here's their phone number. That information is known as traffic. And it's intended to go from person to person. All traffic has to go through what person?
The net administrator.
Net control. Unless the net control station says, okay, Joe, if you have any traffic for Elisa, come now and you can go direct. So essentially, communication with each other is not very formal on the air usually. Communication in a net is formal. And it is done formally to make sure that it stays clean and neat and everything is, everything is what's the word for it? Everything is organized.
But you don't talk unless you're asked to be talked.
That's the other thing. Unless you're reporting an emergency, only transmit when directed. So,
And to be clear, the net is called and then called off, right?
okay. And so not hearing any additional traffic, I'm going to dissolve the net at 12:02 p.m. Pacific time. Thank you, everybody. The frequency is now returned to general amateur use. Have a good day. That is now dissolved.
So question, the way to think of Aries versus races.
Races is not used all that much anymore. Aries is much more well developed.
Like during the storm we had, was that on Friday? It wasn't your normal Monday check-in at 7:30. They activated the Sky Warn. Was that a races or a
Skywarn is its own thing. It's a separate thing. It's in conjunction with the National Weather Service. Aries groups can participate as part in Skywarn and vice versa.
But it's not a races.
No,
So
typically not. No, races is rarely called to order. I mean, that's basically if the government needs, the government agency needs help. So that's not usually specifically called to order. A characteristic of good traffic handling, that is to send a message exactly as you received it. Our job is to store and forward messages. It sounds kind of boring, but that's our job. To make sure that unusual words are received correctly. So let's say I have a last name of McNaughton. Mike Alpha Charlie November Alpha Uniform Golf Hotel Tango Oscar November. Because Mech could be MC and it could be MAC, and they might be different people. So if you have a name or a unique word, you're going to spell it out. You're using phonetics. We use the International ITU phonetic language or phonetic alphabet. Everybody knows it. It is different from military and police. It is used pretty much around the world. Information needed to track a message is part of its preamble, which is its header. The check of a header is the number of words or word equivalents in a message, and if they don't match after you receive the whole message, that means that you missed something or somebody failed to send something, and you need to ask for it again.
Question:
What is a word equivalent?
A word equivalent would be like a number. Like 6284 would be a word equivalent.
Are you counting
That's
the number
one?
That would be one. Yeah.
So 628 would be one word.
Yeah.
Okay.
So it's not counting messages. It's emphasizing on the the spelling like of four would be, Is that correct?
Yeah. I mean, your job is to make sure the message gets across. The content of the message is not important. What is important is that whatever that content was gets to where it needs to go. It's not our job to decide whether or not it's of any importance.
Back to phonetics for a second.
Alpha
It
Bravo
looks like
Charlie Delta.
Yeah, but ITU and NATO look exactly the same. So it is the military phonetics, the NATO phonetics, right?
Yeah, but if
I don't see a difference.
Well, like police departments.
Yeah, they
Able
use the
Baker,
stupid Adam David. Yeah.
Adam David, Able Baker. Yeah.
But the military use NATO, which is the
Okay.
ITU.
Good.
Okay. Just that's one we're familiar with.
Okay, good. When do the FCC rules not apply? The answer is never. There are exceptions, but they're part of the FCC rules. So that's an easy answer. FCC rules always apply. Are you allowed to operate outside the frequency privileges of your license class or even outside of a ham band? And notice these situations. Immediate safety of human life and protection of property, like a dam is about to burst and there's 5,000 people downriver and you're trying to get the information through, you go and use whatever you need. You might have to explain, but you do whatever you need to do. Amateur satellite. We are able to launch satellites. We are able to track satellites. We are able to use satellites. The International Space Station. It need a technician class or higher license to contact the ISS. I talked to an astronaut about 2.5 years ago.
Hey, Scott, I have a quick question about the last item up about emergency situations, and just like a scenario that I went through a couple of years ago and a question I've had since then. That I was my family and I were trapped in a wildfire a few years ago, and we were in it for about 6 hours, and we were able to use listening on ham. We were able to listen to fire and police channels on the mountain. Most of the escape routes were cut off, and we were able to, by listening, able to figure out what escape route was still open over the mountain. And because of the radios, we were able to get out. We didn't transmit during that day at all. We just listened, and we never saw fire or law enforcement, and we were basically on our own. Since then, I've had a question though, that like if, like, I didn't transmit, but if I had transmitted during that time and I'm listening to fire, would they have been able to hear me on that same?
Depends.
Yeah.
And the other thing is that if you are going to do that, there was somebody in Idaho a few years ago who, well, I think it was Idaho. Yeah, it was Idaho, who was calling on one of the wildland firefighting frequencies and trying to direct them. And it was not really an emergency. He thought it was kind of an emergency, but it really wasn't. You have to be able to prove it. And he ended up getting a $34,000 fine. Like, you're not supposed to be there. You have any, ham license, and you have to understand what constitutes an emergency. If your cell phone still works and you can call somebody, it is not an emergency that you need to get on somebody else's frequency with. If there is a legal way to do it, you need to do the legal way first. If the legal ways don't work anymore, then you can do anything you want.
I have a question. February last year, I was going to Arizona from Maryland, and I went to West Virginia, and basically out of nowhere came a snowstorm, and it dumped like 6 inches in 20 minutes, or I don't know, 30, 40 minutes. And there was no cell phone service. And I rescued some people. I have a big truck, and I pulled them up a hill and got them off the road. That wouldn't be a reason. And they did want to call to their parents, but there was no cell service, for them to come get them. And I had to drive, I don't know, usually it takes 2 hours, and it took me 11 to get to the town. That wouldn't constitute emergency, right? Because they had a van and they were warm.
Immediate safety of life or preservation of property.
Okay.
So that's really what it comes down to. Is somebody in imminent danger of dying?
Yeah, Joe, I've thought, just because you said that, I've thought through that, and I thought, well, I would probably want to hit a repeater first and say, hey, is anybody there?
Yeah.
There is, right? Call this number and tell them.
That's right. We do that. We have, there are people, if you get on a repeater and that there are people on it, almost anybody who is on that repeater will be happy to take your message and call 911 and relay your message. Sometimes they'll even hang there for, hours working on it.
And I assume the area that I was in, it was over by Seneca Rocks, West Virginia. There was a fire station there. But I'd assume sometimes cell phone service won't work, but the repeaters would. The ham radio, amateur radio would.
Yeah, likely. Okay. Yeah.
But the amateur radio could have gotten to somebody that their cell service does work.
Yeah, exactly.
Peter.
And actually, if you look at emergencies, like for those of us who live in Oregon, we are in a rather large earthquake-prone zone, which, when it happens, is going to be really, really bad. And it's quite likely that a lot of the repeaters won't work either. What will work is the fact that we can get on the high frequency bands if we still have functioning equipment, and
Right.
we can get on a lot of different bands, and we can, have communications with people who are 500 miles away,
Yeah.
who are outside of the area, who can really relay messages. So just because you're not in an area that is disaster prone doesn't mean that you're not going to be helpful.
Uh-huh.
So
That makes sense.
again, we're kind of like a communications toolbox, pocket, Swiss Army knife. We can do a lot of things. And a big part of what we do is not just having frequencies available to us, it's knowing how they work and what to do and how to use them. All right, let's see. UV satellite mode. That means UHF uplink, VHF downlink. UHF is usually 70 centimeters, and downlink on VHF is usually 2 meters. Amateur radio satellites, mostly FM, but we also do Morse code and data. We also do single sideband over satellites. Effective radiated power on uplinks. We try to limit our uplink power. There's usually a downlink where if we're getting into a satellite, we can hear ourselves. There's often a beacon signal that comes down like Morse code. If your voice is not louder than that, then you're at about the right you're at about the right level.
Hey, Scott, quick
Yep.
question on the repeater piece of it. I've heard that Morse code on there before. What is that?
What does every station need to do?
Identify
Every how much?
10 minutes.
And at the end. So a repeater can use can basically do audio over FM in the form of Morse code to identify itself.
Got it.
And
Okay.
it has to do it every 10 minutes. Some of
Okay.
them do a voice ID, some of them have a Morse code ID.
So if I was to decode that Morse code ID, it should be the station. It would be the station ID.
I do it all the time. That's
Okay.
why I also recommend learning Morse code.
Question for you. I'm looking at a repeater book. Like in my area, it's under Sunderland. It gives you the 2 meter, and then it gives you the frequency, the echo link, the ARES, RACI, Skyward, and then it gives you the, I guess the county, all that stuff.
Mm-hmm.
Where would you find the actual Morse code identifier in that?
What's the call sign?
You mean the
repeater has a call sign attached to it.
Oh, you mean the amateur club radio call sign?
Yeah.
Oh, that's K3CAL.
Okay, so every when it's in use, it'll every 10 minutes it'll say da 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 da, which is K3CAL/R.
Okay, so it's and they got more than one.
Yep, you can have more than one with the same call sign.
Okay, so it'd be throwing out in Morse code the K3CAL.
Mm-hmm.
You did mention a /R on the end to indicate it's a relay.
It can be. Sometimes you can put it there. You don't have to, but a lot of people do.
It's got a /Sunderland, so that separates it from.
It's a self-identified identifier, indicating that it's a repeater station. It's not required, but some people do it to differentiate. Okay, if you are using too much power on a satellite uplink, you'll block other users. LEO is a low Earth orbit satellite. Most of the satellites that HAMS put up are low Earth orbit, which is not geosynchronous. There is one geosynchronous amateur satellite. Unfortunately, it is in the Eastern Hemisphere, not the Western Hemisphere. And we can't get to it unless you happen to live in very far Eastern Brazil. A satellite beacon, it was put up by the Qatari Amateur Radio Society. So that would explain why it's on the Eastern, in the Eastern Hemisphere. They want to be able to use it. A satellite beacon contains information from a satellite.
You mind if I get confused between what is a beacon again?
A beacon? A beacon is just an informational signal.
So it could be, I know a space station, satellite. What Earth type beacons do they have?
Oh, we have propagation beacons. So like for instance, on a mountaintop, you might have a um, you might have an antenna like in a remote location on a mountaintop, solar powered, a 10-watt transmitter on 6 meters, so on the 50 megahertz band that just continually sends out my call sign /B and lists the location. And that's a propagation beacon. If somebody hears it, they know that the 6 meter band, which is not usually an open band to anywhere, is experiencing propagation to somewhere. And that can be an identification, that can be a notice to people that 6 meters is alive.
And if you're flying aircraft, like I used to fly small aircraft,
well, those are
a
NDBs.
VOR,
Yeah.
that would be considered a beacon.
Mm-hmm.
Okay.
It's just an identifier of where I am and what I'm doing.
All right.
So a satellite beacon can contain where it is, what the altitude is, what the battery level is, any number of different things. Who can receive telemetry from a space station? That would be anyone, because anyone can listen. Satellite tracking programs. We have a group called AMSAT, which is the Amateur Satellite Corporation. That keeps a listing of every satellite that is flying around in space that contains amateur radio equipment. And using Keplerian elements, you can track and get a map of where that satellite is at any given time, which is cool because then it can tell you when it's passing overhead and how you can get in contact with it and talk to other people using it.
We did that last night with the space station, but I just used an app. Yeah.
Yeah. A lot of repeaters, a lot of satellites contain repeaters on board. So you can
That's
have
so cool to see too. I didn't mean to interrupt, but I did that. I got up one morning at 4:30. Cat woke me up, and I looked at that ISS detector. And 15 minutes prior, after I looked at it, the satellite came by, and you could see it, a dot in the sky, going down on the horizon.
So there's a website called Spot the Station, which allows you to look at what the ISS is doing with respect to your location and when the passes are going to be. And you know what? There's no easier way to make a contact through the ISS than physically being able to see it in the sky at sunset and aim your antenna at it. I've done that.
Really? That's cool.
That way you don't have to guess where it is. You can actually see the dot going through the sky.
Yeah.
Now, the other thing is that satellites travel at about 17,000 miles an hour. Everyone has probably heard of Doppler. Doppler is what happens when a fire truck goes by and the pitch of the siren changes, right? Doppler actually has an effect on satellites with RF. I mean, if you think about 435 million cycles every second, right? 435 megahertz. Doppler actually causes a shift because it's moving at a significant fraction of the speed of light. It actually causes the radio waves to shift frequency, and you have to tune your radio accordingly.
Okay.
To be able to operate a satellite. When it's far approaching you, far on the horizon, its Doppler shift is maximum. As it goes overhead, it's 0, and as it goes away, it gets stretched out, and your waves get longer. If they get longer,
what did you do? Did you just start tuning your radio as you were trying to talk to it, try to keep up?
I have multiple different frequencies programmed into my handheld.
Gotcha.
And I change them based on where the satellite is at the time.
Yeah.
So the ISS station would be an example of that?
Any low Earth orbit satellite, of which the ISS is one.
Cool.
Spin fading, most satellites are rotating. As the satellite antennas rotate toward and away from you, they will disappear from view, in which case they will fade out. Okay, contests. Contesting is making as many contacts as possible during a specified period. It's radio sport, one of my favorite things to do. I don't know if anybody noticed the shirt. Notice the shirt I'm wearing?
If ham
radio were a sport,
it was a report, I'd be a jock.
There you go. So I enjoy radio sport a lot. It is an outlet for my competitive juices. And I don't usually get hurt doing it, unlike other sports that I play. When contacting another station in a contest, because the goal is to make as many contacts as possible, you send only the minimum required information. You typically don't chit chat unless it's somebody you know really well and you haven't seen them in a while. A grid locator, this is another thing that I sent. This is the grid map of the United States. Each grid is broken up, is 2 degrees in longitude by 1 degree in latitude. And the reason this is done is because, in particular for VHF operation, let's say that somebody's in Boise, Idaho, which is in Delta November 13, and you tell them that you're in Oregon. Well, okay, they could be almost due north or almost due south or due west or anywhere in between. So by specifying I'm in Oregon, Charlie November 84, they have some idea of more specifically where to point an antenna. So that's why we use grid squares. Letter number designator.
Is that a like a radio thing, or who defines that grid?
It's worldwide. It's a worldwide definition of it's called the Maidenhead Grid Square Locator Map, based in named for Maidenhead, England.
Gotcha.
And it starts at AA00 and goes all the way up to the North Pole. Goes from the South Pole to the North Pole.
I assume certs are the amateur radio get involved with certs and use those maps. I assume they do.
I mean, we use them all the time. We don't have anything to do with specifying them, but we do use them everywhere. Location of noise sources or jamming, we use radio direction finding. Directional antennas, you point your antenna and you pick up where the signal is strongest. We do this for fun. This is known as fox hunting or radio direction finding. We often go out in parks and hide a transmitter somewhere and everybody goes and looks for it. IRLP is the Internet Radio Linking Project. IRLP uses VoIP, which is voice over internet. Voice over internet is used to allow using digital techniques. Using digital techniques allows hams to combine internet and radio protocols. Echolink is a form of digital communications, which you can register your call sign and then you can install an app on your phone. And again, use the internet for a large part of the communications link. And then once it gets to the other end, it can be placed out on the air and you can have an on-the-air conversation with somebody.
Quick question on that.
Yep.
On the net, they did a Monday check-in, with the net, and people were asked to join on the Echo Link. How would they know? Oh, I guess there's a number that's given out. If you want to join it, basically you do your call sign and then you tune. Where do you put the information in for your Echo Link?
Well, first of all, you get an account, and once you have an account, you can sign in. And once you've signed in, you open up the app, and I might as well. Let's see if I can do this. I have Echo Link on my computer, I think. Let's see, station.
And that's really new, though.
Oh, it's the last 20 years.
Oh, is it?
Yeah.
I don't remember them talking about it years ago in my first class, but
Here. So when I'm signed into Echo Link, these are all the Area 7. Notice I can go to Canada, I can go to Europe, go to Belgium. These are all stations that have Echo Link tie-ins. I can do this from my computer. I can do this from my phone. I can be pretty much anywhere. South America.
It's part of DMR, correct?
No.
It's just separate, completely
It's its
separate.
own thing. Yep. It's a voice over internet protocol.
Okay.
So
And so
CE5.
help me out. What would I use this for? I want to talk to someone
Okay.
in China. So is that what I'd use it for?
So let's say that I'm on a work trip, which I do a lot, and I want to check into my local repeater's 2-meter net. My local repeater is on Echolink. I can log in, look up my repeater, connect to it, and talk to other people as though I'm physically sitting in my house.
Okay. That's cool.
You do that
Can
right
it
on
go
your
the other
phone?
direction where you can
It's
talk
it's
to
bidirectional, yeah.
So you could do your net check-in when you're away,
I can
basically.
participate if I have somebody I want to talk to over the repeater. They can be in a car talking through the repeater, and I'm sitting in a hotel room in Austria,
Is that through your iPhone then, right?
or my computer, either one.
Okay.
App
Yep.
or
So you can open up an IRLP node over dual tone multi-frequency. Everybody who's got one of these handhelds sees that little keypad there. That keypad, if you're already holding down the push to talk button, transmits touchtones. DTMF is also known as touchtone. An amateur radio station that connects other amateur stations to the internet is known as a gateway. So, the gateway between radio and the internet. All right, here we go. My least favorite part, but very important part. Part 97. Part 97 is the rules and regulations that govern amateur radio in the United States. They are administered by the Federal Communications Commission. And if we go to and look for Part 97 rules, you will have no trouble finding Part 97 rules. They are maintained by lots of different organizations, including the government. The other place to find them is you go to the ARRL website, and here is Part 97. Here we go. Part 97. Notice, isn't this light reading? Light reading, but this is the definition of everything. This is all the rules and regulations that govern absolutely everything on every band, every mode. There's all the frequency allocations and what they're used for, and on and on and on and on and on. So, interestingly, the very first part of the FCC rules for governing amateur radio is basis and purpose. This basically is a list of our reasons that we are allowed to exist. And this is literally the first chapter, the first paragraph in the first chapter. And it is very, very important to understand this and take a look at it and understand why we're allowed to do what we're allowed to do. So important that I'm actually going to put it out here in the chat. Okay. So there may be some questions as to which of the following is a part of the basis and purpose. It's important to understand what those are. Right? It is not put there so that we can just use a radio. That is not why we're allowed to exist. There are obligations that we have to meet. Those obligations come from the fact that we are given these immense privileges, which I think you now see, having gone through a day and a half of this class, we have some pretty freaking immense privileges available to us. We can do a lot of stuff. Well, whether or not you intend to ever use them is really kind of immaterial. Our privileges allow us to do an amazingly ridiculous amount of things. So in order to justify that, there are some things we have to give back. A beacon is a station transmitting communications for the purpose of observing propagation or related experimental activities. As we were saying, that could be a transmitter on a 12,000-foot mountain that's covered with snow most of the year that is saying from this location, here, can you hear me? Can you hear me? Can you hear me? Part 97 of a space station is 50 kilometers above the Earth's surface. Willful interference. When are you allowed to interfere with somebody, even if they're really pissing you off? And the answer is never. We are equipped with this thing called a tuning knob. I recommend using it. Which of the following entities recommends transmit and receive channels and other parameters for auxiliary and repeater stations? We have in every section, every state, something called a volunteer frequency coordinator. The frequency coordinator has nothing to do with the FCC. It has nothing to do with the ARRL. This is basically a group of people who has volunteered their services and is respected by the other people in their section or state to make sure that everybody learns how to play together. They're the ones who pick what parts of what band are used for what purpose.
Would they be involved with, so just an example, I had found a repeater here that was, is still listed on my GMRS, getting some feedback. And I'm not sure who that is. And I reached out because I knew the person that was assigned their call sign. I knew who that was. I got a hold of them. I said, well, yeah, that's not there anymore. We actually moved that frequency to somewhere else because they were interfering and it was better to be over in this other area.
Yep.
That would be these people that would do that.
Yep.
Make those.
They're the ones who keep the
Okay.
peace. They're the ones who decide what frequency gets used for what and what repeater at a given altitude, for instance, or a given height above average terrain and a given antenna pattern is going to interfere with another one down,
Okay.
Out at the coast or up in the mountains somewhere else. So they're the ones who do the coordinating of repeaters. And
How would you find that?
frequencies.
How would you find them?
Where do you live?
Yakima.
So you're in Washington. You're in Eastern Washington.
Mhm.
Washington State Repeater Coordinators.
Okay, so you just do a quick Google search.
WWARA, that's Western Washington, and I don't know who does Eastern Washington. I don't know where the dividing line is. But yeah, here's the National Frequency Coordinators Council, which is NFCC. And here's the NFCC. Yeah, we don't get involved. Let's see. Not an official NFCC sponsored site. Okay. Members. Okay. Eastern Washington. Okay. So not this group. But yeah, I mean, it'll be fairly well known at some point.
Okay.
I don't know who it is for Eastern Washington, but somebody does.
So you gave me a name earlier of somebody.
Mark Tharp. Mark Tharp.
So that'd be like I could just say, hey, Mark, he probably would know.
Well, the ARRL doesn't get involved in frequency coordination, but I'm sure he would know who it is.
Okay. Okay. Just curious how that all works.
Yeah. In fact, I can send him a note right now.
There's a couple guys that I'm talking to that were thinking it would be good to have another repeater on a mountain that's close to here.
Mm-hmm.
And I'm assuming we'd have to start talking with those folks around, is it even possible and how, and what frequency would be available and all that.
Yep.
Okay.
Okay. I just sent a note to Mark. He'll probably answer me within a couple hours. Okay. Who selects a frequency coordinator? Anyone in a local area who is eligible to put up a repeater. Or if you have a repeater and you're ready to build it, you can run for the board. Frequency allocations and power limits. 6 meter band. All right. So now we start looking at this. 6 meter band covers 50 to 54. That's the 6 meter band. So we look back here and say what frequency is in the 6 meter band. Clearly it's that one. This is where you just got to learn to memorize. 146.52, etc., etc. That's obviously right here. 146.52 is here. It's on the 2 meter band. On what band does a technician class operator have phone privileges? That's the 10-meter band. Your limits are 28.3 to 28.5. Where can single sideband phone be used? In bands above 50 megahertz? In at least a little bit of every band. So you look over here, SSB and weak signal. It's kind of this olive color, and you see that a little bit of it exists on every band. Morse code only. You look down here. See, oh, okay, that's the red zones. CW is red. There you go. 6 meters, 2 meters, 1.25 meters. This is not even on that chart. So this is truly memorization. The 219 to 220 segment, this was a result of a deal made with UPS many years ago, where they took 220 to 222 and they gave us 219 to 220. Yes, it's 2 for 1. We lost out on that. That is, and we used to be able to use it for lots of other things. Now we can only do digital message forwarding systems only. Don't even ask me what it is. It's data forwarding of some kind. So
And the 219, 220 was, can you go back to that real quick? And
yep.
120, 125, 1.25.
Because here it is. 219 to 220 is in the 1.25 meter band. We call that band 220. Why should you not set your transmit frequency to be exactly at the edge of an amateur band or subband? We covered that. Modulation sidebands, transmitter frequency could be off. Your transmitter could also drift over time, especially if it's an older tube radio. Some places we are the secondary user. That means we are not primary, which means that if we find a primary station, we have to let them have the frequency and we move away. That actually happens not that often, but it does occasionally happen. Maximum peak envelope power over 30 megahertz is 1500 watts on even for technicians. On the HF band segments down here, where you have the blue hash and the green hashes, you're limited to 200 watts. I don't even run 200 watts. So, you know. For which license classes can you get a license? Technician, general, and extra. Don't ask me why it's called amateur extra, because I don't know. Honestly, I don't know anybody who does. Why it's just not called extra. Normal term for a license is 10 years. You're able to start operating as soon as your license allocation appears in the database as active. You're allowed to have one primary station license, and that's all. If you were in the database, your license is there. That means they used to actually send you something in the mail. They don't do that anymore. If it shows up in the database, it's valid. Who can select a desired call sign? Any licensed ham. It has to be of the appropriate license class. So we call all call signs in the United States either 1x2s or 2x1s, 2x3s, 2x2s, 1x3s. That because every call sign has a single digit in it, which represents the call area in which you live. And beyond that, you have a prefix like KF and a suffix, which is after the number. You can have 2x1, for instance, KA1X. You can have 1x2, W1XX. This up top would be a 2x3. But what's important to note is that 1x3s and 2x3s can be chosen by anyone. You cannot pick a 2x2, a 2x1, or a 1x2 unless you have an extra class license, or in some cases, an advanced class license. But you can't get an advanced class license anymore. So N7JI, for instance, would be of a 1x2 format. You can only request that with an extra class license. N7JII is a 1x3. You can request that with a technician class license. And when you fill out your FCC form, because I know some of you are going to request what's known as a vanity call, that is the call sign you really want after you get your sequentially granted call sign. some of you are going to do this, I am sure. And there is a very important thing to remember, which it amazes me that after people go through the process of licensing that they still make this mistake. United States call signs start with the letters W, N, and K, and anything AA through AL. And that is all. I know, like, occasionally I'll see somebody on Facebook post a question that says, my call sign got rejected and I don't know why. And say, well, what did you request? And I requested B0BBY. I thought that'd be cool. The call sign that starts with the letter B is allocated to China. So clearly the FCC could not grant this. Or they might get really cute and say, I want M1KEY because my name is Mike. They requested a call sign that is allocated by Great Britain. So it's important to remember that when you're asking for a call sign, remember that it has to start with a W, an N, and a K, or a K, or if you're an extra class, it can start anything AA through AL. But remembering that the second letter can't be an L unless you're in Alaska.
I have two questions around call signs.
Mm-hmm.
First is the minimum and maximum digits or letters or whatever it could be.
One digit.
It has to be at least one. Is there a maximum?
Well, that's it. One digit.
Okay,
You can
and
have one
then
number.
my other last question is, I could not care any less about what it is. However, I do not want particular things in it that I'm very specific about with emails, such as IL1, certain letters that are interchangeable looking when they're written and typed and not capitalized or capitalized, whatever. If you don't request a specific one and they give you one,
they will
and then
never
you're
they
like,
will never
"I
give you
hate it."
something. They will never give you something that you don't request unless it's your very first one.
It is
the first license you get is always going to be sequentially allocated. But anything beyond that, you only get what you request.
So if you get a like yours N7JI and I'm like, I don't want an I, and I would have to pay and get a vanity one.
Yeah.
Real quick.
And you,
sorry.
Go ahead.
If you, my father-in-law passed away. What do you need to? I assume you test first. They give you a call sign,
and then you can
ask for
request.
vanity.
Yeah.
Is that,
and if it hasn't been, and if it hasn't been assigned, and it's outside of 2 years, and nobody, what's the call sign if you were looking for it?
what is it? W3 ODY, I believe.
Okay.
ODK.
ODK. Okay, so you'd have to look and see if it's available. How long
It
has it
is.
been? How long has it been?
I'd have to look on my phone to see, but
I mean,
it's been like 5 years.
Okay, so it's outside of 2 years. If it's inside of 2 years, you could actually request it when normally you couldn't because you're a family member. If it's outside of 5 years, anybody can request it.
But you have to wait until they give you a call. The FCC gives you a call sign first,
right?
Or can you?
You always have to get a sequential call sign first.
Okay.
When you register for course, then what else are you doing before you are showing up to one of these test sites that they gave, like it's on the 27th at 6:30 p.m. Pacific? If you're going to take it online and you sign up for course, what is there anything else besides being on course that you have to do to go take your test?
You just have to have an FRN, which is the
okay. Thanks.
That's it. Yeah, and you have to bring ID with you. So
okay, thanks.
My question.
All right, Luetta was next.
Was that you were saying for Alaska, and that caught my attention. So I have a 2x2 right now. It was assigned to me for my tech, but I heard you say that there's certain things. So in the state of Alaska, you have an L as the second letter in the second set. Is that correct?
No, it has to be, it is an L in the prefix. You don't have to, but that's what you'll get.
Okay, so it's like, that's why I have KL now.
That's right. And your call again is KL, what was it, for IZ?
KL4 India Zulu.
IZ. Okay, yeah. And the other thing is that if you never have to change that if you don't want to. Just because you upgrade, you don't have to change it.
Oh, okay. Thank you.
Did anybody call you Is?
I can't remember.
Louetta, does anyone call Louetta, does anyone call you Is? That's actually a pretty cool call sign. It's a good Morse code call too. Did it dotted it. Okay. Grace period. If your license expires, you can't operate during the grace period, but within 2 years you can ask for it to be reinstated. If it's you cannot operate. Okay. Which of the following is a requirement for issuance of a club station grant? A club has to have 4 members. You also have to have a constitution. What can happen if the FCC can't reach you by email? If they try to send you an email and it bounces, they can pull your license. It used to be that would happen with snail mail as well, but they don't do that anymore. One thing that everyone's going to ask, I guarantee somebody's going to ask in this group, can I use a post office box? I don't want people having my street address. Yes, you can use a post office box. No, don't use a fake address. No, don't use a fake address.
Can you add a PO box after registering? I mean, by default, you get a call sign with your address. Can you go back and edit it and change it to a PO box once you get one?
Sure.
Okay.
A lot of people who travel a lot, they live, they do the RV lifestyle. They have a drop address for their email, for their mail. That's fine. What can happen if the FCC, we talked about that. If your license, if they can't get a hold of you, it's the same question worded 2 different ways. If they can't get a hold of you via email, they can pull your license. From which of the following locations can you transmit if you're on a boat that's in international waters and is U.S. licensed? I would still ask the captain, but you're legal to use your U.S. call sign. It's part of the United States. When are you allowed to curse on the air? The answer is never. We are subject to the same fines for over-the-air communications as any TV or radio station.
Hey, Scott, are you sharing your screen?
That's a good question. Oh, no, I'm not. Thank you for pointing that out. That's the first time I've screwed that up today.
Problem.
Yeah, okay. You are not allowed to curse on the air. There's a good rule of thumb. If you wouldn't say it to a 5-year-old, don't say it on the air because there might be a 5-year-old listening. When are you allowed to transmit music? We are not music stations. If music happens to come through your microphone, like it's playing in the background, that's kind of okay. If it's incidental to an authorized retransmission of manned spacecraft communications, this rule comes from when NASA used to retransmit on their ham repeaters all of the ISS and all of the space shuttle communications, including wake-up calls. And the wake-up call was done with music. So that was weird to hear, but it's legal because it was a space thing. Transmitting messages to obscure their meaning only when transmitting control commands to a space station or a radio control craft. So we are not allowed to encrypt messages. We are not allowed to speak in codes because that is not our purpose, unless we are trying to run a radio control craft or a space station because nobody wants it to receive codes and get hacked and then crash.
And by code, and by codes, you mean like 10 code or something?
Well, no, 10, I mean, we don't use 10 codes because it sounds too much like CB. I mean, but you can. I mean, you can use a code so long as its meaning is known and well known. I mean, if you think about it, like digital mobile radio, what does that sound like? That is obviously encoded, but using the codec, anybody can decode it. It's not obscured. However, like things that aren't allowed, for instance, like, hey, so 641822, and somebody has a code book that only they have, even though those are, normal words, that has an obscured meaning because nobody else has the code book except one other person. It has to be a well-known coding and decoding scheme that anybody can just do. Otherwise, we're not
That's
allowed
not-
to do it.
Is that how privacy codes work?
Well, but yeah,
Anybody can decode them, you can use them.
yeah. That there's no expectation of privacy on the air for what we do.
So like Q codes are okay.
Q codes are fine because everyone knows what they mean. With which countries are we prohibited from exchanging communications? If the ITU, which is the United Nations organization, has been told by a country that we're not allowing that. Yemen did that with Israel. There was a group of Italian hams that went to Yemen and they operated and were told by the Yemeni government through the ITU that they were not allowed to contact any Israelis, even though it's less than 1,000 miles away. That's just what they said. In which of the following circumstances can the control operator of an amateur station receive compensation when it's incidental to classroom instruction? In other words, if you're a teacher at an educational institution, you can still be given your salary. If somebody were, for instance, to wanting to bring a pizza to a bunch of hams that were doing, emergency communications, that would probably be okay, but you can't receive pay. When can you use your station to notify other amateurs of equipment for availability of equipment for sale or trade? All right, we can't run a business. However, if you sell stuff once in a while that is related to amateur radio and you don't do it frequently, you show up on a swap net once a week and say, okay, I've got this and this and this and this, and you're clear you're not running a business on it, you're able to do it. Like, for instance, a powered desk for a ham station might be okay. A piece of radio equipment, definitely okay. A comfy couch for your shack, maybe not so much. But maybe, it'd have to be justifiable. Broadcasting, don't use the word broadcasting for your transmissions. We transmit, we do not broadcast because a broadcast is intended for the general public. Even though the general public can hear what we're doing, we don't typically do that. No, we are allowed to send one-way communications, and the one that is not allowed, again, is broadcasting. However, we can do one-way communications for code practice or bulletins, which are intended for the ham community. So when are we allowed to support broadcasting, program production, or news gathering? Assuming, this is very important, no other means is available. So basically, if there's something really bad happening, that means immediate safety of, you might recognize this from before, immediate safety of human life or protection of property. When that happens, all bets are off. You can do whatever you need to do. So what type of communications are we allowed to talk about? The incidental to the purposes of the service, at which point you have to go back to why we exist, and remarks of a personal character. How are your kids doing? Yeah, I'm going to Detroit next week. I got a doctor's appointment on Thursday. Right? I used to laugh at the content of the personal character comments when I was a kid at 15, because I'd hear people talking about their doctor's appointments. Now I'm 56. Now I make those comments. I'm sure there are people who are out there who are laughing at me. And yes, I do have cataract surgery coming up in 2 weeks. So when can an amateur station transmit without a control operator? The control operator is the person who is responsible for what is going out of the antenna, and the answer is never. Someone always has to be responsible.
Scott,
yes.
I'm terrified of missing this. When is the next bio break?
Well, I was going to just run to the end.
Okay.
Because we're almost
okay.
done. In fact, we are, well, the end is on page 120 and we're on page. Okay, we are on page 115. Would everybody be okay with a 5-minute break?
Sure. Yes.
All right. 5-minute break.
Thank you.
Yep. I don't think I've ever heard the term bio break before, but I like it.
Scott, you mentioned needing an FRN number to take the test.
Mm-hmm.
Does that take a while to get, or is it
No,
pretty?
it's really fast.
Okay.
You go to the FCC course.
Yeah, I
system.
Googled it. I found it.
So how you doing, Elisa?
I'm great. I'm great. Happy to be in Oregon.
Yeah. Yeah, happy to be back for me. A lot of travel. A lot of travel.
Where have you been? Any place fun? Or just work?
No, just work. Oh, well, no, I mean, not terribly unfun. I forced myself to do something this past a week ago. I did a work trip to Mississippi and then a work trip to Alabama, and in between I squeezed in a trip to the Hamvention in Dayton, Ohio, which I hadn't been to in 24 years. So,
wow,
it was actually a blast.
I'm gonna ask.
It was a blast. Yep, 1,500 miles of driving, extra.
That must have been more tiring. The driving.
Yeah, I mean, it's just time behind the wheel. It's totally worth it.
Looks on tape, make it doable.
Actually, yeah, I mean, I got to listen to a lot of music and see a lot of interesting areas of the country that I hadn't seen in many years. And yeah, it was a lot. And then I was there for how long? Let's see, I got there at 7 o'clock in the morning and I left it. I was there for 30 hours. Oh my God. That's all. I was there for 30 hours. And then I got to go to a Cincinnati Reds game that night. And then go to Alabama and go to work. But I figured if I was anywhere east of the Mississippi, that was an easier trip than going from Oregon. All right, y'all ready to go again? This is truly the final stretch. Okay, so there are two parts of a license. There is a control out. There's an operator license and a station license. So an operator license licenses you, the person. A station license it basically licenses the equipment that you are allowed to put together. So I have, for instance, a station license for N7JI, which I can then use for my equipment. I also have my operator license for N7JI, which I could use on my equipment or on any other piece of equipment. So if let's say I put together a club station. A club station has a station license. What privileges does that station have? What operating privileges does that station actually have? What do you think?
Nothing.
Nothing.
I,
That's right.
could I have a little bit of clarification here? A station license. So that's not the equipment that I'm running
Yes,
as
it
a
is.
ham.
Yes, it is.
Okay, it is that.
Yes.
So then I have to get
ahead.
my ham license and a station
They're
license.
the same. There's two parts in your license. You have call sign that licenses you and allows you to use that call sign on equipment. But let's say that you create a club, and it's the I don't know. Let's see. The Automatic Amateurs Radio Society, right? You create a club of 4 people, and there's a trustee, and you volunteer to be the trustee of the station, and you get the call sign, and you get a call sign for that station, and you build a club station, and you look at the license, and it says station license, Automatic Amateur Radio Society. Here's the call sign. There are no privileges associated with that. There is just a station license for the call sign. So if somebody walks into that station without a license, are they allowed to use it?
No.
No, because it has no privileges assigned to it at all. There's a trustee who is responsible for its proper operation, and the person who walks in with a license can use their privileges to operate that station. So it's an important distinction between the station license and the operator license. The
If-
control. Go
If
ahead.
I'm just as an operator from my home base,
Mhm.
am I considered a station? Do I need a station license?
It's if you have a ham license and it's an individual, you have both.
Okay.
It covers both. So
Is the
go ahead.
call sign for the station just used for like the repeaters, etc.? If someone walks in with a license, they're going to use their call sign.
Not
But if
necessarily.
they could use the station's call sign.
They can use the station's call sign. And that's why there's a thing called a trustee. Now, what's interesting is that let's say that the trustee has a technician class license. So you would expect that if that call sign ever showed up, what privileges would it be able to use? If you look it up and the trustee has a technician class license, you would expect that it would go no higher than a technician class license. But let's say that an extra class license walks into the station and decides to operate and uses that call sign and is down on the high and shows up on the high frequency bands in an extra class band. That might raise some eyebrows, right? And in fact, that is why when an extra class license operates that station and it's using privileges higher than the trustee has, they actually have to state that it's being operated by this person. which is a real pain. So the
And
rule. Go ahead.
would it also apply that if I got a station license and I got it with a 2x1 call sign, that only experts could run that call station?
Extra. Keep going.
So if I got the 2x1 designation for my station, that would mean that only somebody with that high of a license could run that station.
Actually, no. They're allowed to use that station, but only if they're the control operator. They're only allowed to use it in parts of the band that they are legal to use it in. So let's say like you're Stanford University and your call sign is W6YX, which it is. They've had that call sign for a long time. All right. That's an extra class call sign. They have an extra class trustee. And a technician class operator walks into the station and sits down. What frequency privileges are they allowed to use? Their technician class privilege. Right. They can still use the station call sign, but they can only use it in the tech part of the band.
Even though they have an extra license?
They don't have an extra license. The trustee has an extra license. There's a very important designation between station license, trustee, and operator license and control operator. The control operator is ultimately responsible for what goes into the microphone or what is being sent. The control operator is the person who determines how the station is working. So let's say that let's say I show up as an extra and a technician shows up and the technician sits down at the station and I am the control operator. My privileges, my extra class privileges transfer to that person for the time being because I have volunteered to be the control operator. What if I go out and walk to the bathroom?
It goes back to the operator that's using it.
Yep. So as control operator, I have accepted the responsibility for proper operation of the station.
You co-sign for a loan.
Yeah, pretty much. Okay. So the control operator and the station licensee are both responsible for proper operation.
If the technician violates that, would that be on you?
Depends what they're doing. If you are operating in the if they're operating in the extra class band and you volunteered to be the control operator, then yes. So here's another one. An unlicensed operator comes in and we're following third-party agreements. We're going to get into that in a minute. And they're on the air and they don't have a license at all. Can they talk on the air?
Is there a control operator there?
I am volunteered to be the control operator as an extra class licensee.
Okay, and now your 5-year-old has come in and wants to talk on the radio.
Do it all the time, actually.
Yes, yeah.
I do it all the time.
Probably yes.
We run a museum station here in Eugene. We have unlicensed kids on the air literally 6 days a week.
So that means yes.
And the answer is yes. If one of the kids decides to go a little nuts and start cursing on the air, whose fault is it?
Mine.
Yours, the control operator.
And my job at that point is to take the microphone and slap it out of their hand and say, I'm sorry I had to do that. You're not allowed to say that on the air.
Get the soap out.
Yeah.
Never 5-second delay. 5-second delay.
Yeah, we don't have that. Okay, so who is accountable if a repeater inadvertently retrans? Okay, now you'll remember the difference between a control operator sitting at the desk versus a repeater. A repeater is an automatic device. It's operating in automatic mode. I'm actually the trustee for our club repeater. If somebody gets on the air and starts let's say playing music or playing a recording, an obscene recording or something, whose fault is it?
The originator.
Operator.
It's the
Original
originator.
person.
It's not me because it was operating in automatic mode. Now, it would be smart for me to grab the shutdown code and remotely shut down the repeater and make them go away. But I'm not obligated to do that. It's their fault. They're the ones who could get fined. What determines the transmitting frequency privileges of an amateur station? And that would be the class of operator license held by the control operator. The control operator is ultimately responsible for those frequencies.
Is there actually FCC staff that track this stuff? And
so
maybe not
okay,
anymore.
right. Okay, so how much money does the FCC take in for from amateur radio operators after the $35 licensing fee, which doesn't count?
Zero.
The answer is
$8
zero.
a year?
No, it's zero.
Oh, ARL.
Nothing.
I'm sorry. I got confused on ARRL.
Yeah, no, the FCC takes in nothing. Ultimately, who is responsible for enforcement of the law?
All hams.
Well, no, it's the FCC. However, for a long time, I mean, we've been around since the early 1900s. We are largely self-policing because somebody else doing something bad makes everybody look bad, including me, including every other licensee. So we try to take care of things before they get to the level of the FCC. And yes, submit a request, FCC complaints, they don't care.
How about fines? I mean, have you ever heard of anybody?
People get fined. Yeah, you got to do something pretty egregious. And
Yeah.
the FCC is rarely the initiator. It's usually somebody's made a recording or something and say, this is continually happening. And we've talked with them and tried to get them to stop, and they will not stop. And then so there is something called a volunteer monitoring program where there's a bunch of very well-trained amateurs who listen to the ham bands. And, if something happens, the ARRL runs the program. They will contact the ARRL, send it to the administrator. The administrator, if there's no resolution, can refer it to the FCC. But the FCC, if they really want to, the FCC is very good at doing direction finding and identifying transmitters. They're really good at it. But it also costs money and it takes personnel. So, we like to solve things.
So
ourselves.
do they do that retroactively? I mean, is everything recorded or something? How do they?
No, they just wait for it. They'll wait for it to happen again. And this time they caught him in the act.
Okay. Huh. Interesting.
Because usually if somebody's going to do something, it's not a one-time thing. If it's a one-time thing, it usually it happened in the past and no one's going to know. But if it's something that happens repeatedly, there's somebody who has a vendetta against somebody else and they get on a repeater, and whenever that person shows up, they just jam them. It's going to happen again. And those are the kind of cases that the FCC then, said, you know what, you may say you have a First Amendment right to do this, but you kind of don't. So, okay, control types. Amateur station control point. If I'm holding a radio in my hand, the push to talk button right here is the control point. That would be local control. Remote control, we actually do this a lot. We operate a station over the internet using remotely controlled radios. We actually do this a lot. What happens if the radio fails or the internet link goes down? The radio has to stop working. There also has to be somebody physically sitting there at all times operating the radio. So if you leave your desktop and somebody else walks up to it, you probably don't want that to happen. An example of automatic control is repeater operation. Okay, station identification, repeaters, third-party communications. We pretty much covered all this, so this should be quick. How often are you required to identify? Everyone?
10 minutes. 10 minutes
yeah.
and after your transmission.
Yep. So when is the end? I don't know. It's whenever I decide is the end. So every 10 minutes and at the end. You don't have to identify when transmitting signals to a model craft, like a remote controlled car, remote controlled plane. Yes, people actually do that. We often use the 6 meter band for that. When you identify, you can have a conversation in any language you want, so long as it's a language that someone else understands. You have to identify your call sign in English. I've been in Chile operating. I've had English and Spanish conversations there. I had to identify my call sign in Spanish. How can you identify a call sign? How can you identify yourself? Morse code or phone, which is voice.
Wait, I'm sorry. Back up. The language may you use for identification. I assume that's in the U.S.
In the U.S.
You just said in Chile.
Talking,
so
we're talking an American license. So
okay, but okay. So if you're in a boat in international waters, it's still U.S. Okay.
Yep. Okay. The phonetic alphabet is strongly encouraged, and use the ITU phonetic alphabet. We also very often will be on a net where we are doing a public service thing. If you are lucky enough to live in Oregon, we do something called, well, it used to be called the Cascade Cream Puff, which is a mountain bike race. There's another one. We do something called the Oregon 200, which is insane. It's a 200-mile foot race through the Cascades. We have another one called the Waldo cross country run, called cross country race, and we are talking some serious backwoods areas up in the wilderness where there is no communications whatsoever. So, race headquarters, aid station 1, aid station 2, aid station 3. Those are tactical call signs, which, depending on who's using it, it doesn't really matter who's using the station. There could be 6 different operators stationed at race headquarters. However, when you transmit that, you may call it race headquarters. How often do you have to give your real call sign?
10 minutes.
10 minutes.
And
at the end.
There you go. In other words, you still have to follow the rules. It's actually fairly straightforward.
If you have the main one and you've got, let's say, 6 other tents that are separate radios, each of those has to update every 10 minutes.
Well, only when you're transmitting. If you're not transmitting, you don't have to do anything. But as soon as you transmit, you have to identify within 10 minutes. Period. That's just following the FCC rules. Okay, self-assigned identifiers or indicators. So you can use the words stroke, slash, or slant. So we do not typically have to. Let's say your call is KL4IZ, right? Loetta, your call is KL4IZ, right?
Yes.
Okay. So if you were in, let's say, Oregon, could you still use KL4IZ?
I have to, because that's me.
Right. But would you have to put anything else after it to identify you were somewhere else? Because you're not in KL4 anymore. You're not in Alaska. Would you have to identify in some other way? And the answer actually is no. You could just still keep signing KL4IZ. However, if you wanted people to not think that they were suddenly hearing somebody in Alaska, you might sign KL4IZ stroke 7.
And what does a stroke 7 mean?
Do you know the call sign areas of the United States? All those numbers, like KL is Alaska, KH is Hawaii, and then 0 is the upper Midwest, 8 is like Ohio, Michigan, 9 is Indiana, Illinois, 4 is the Southeast, 5 is Texas and like the Gulf Coast, 6 is California, 7 is basically the whole West. 1 is New England, 2 is New York, New Jersey, 3 is the Mid-Atlantic. So depending on where you are, you might want to change how you're identifying. You're not legally
And what are
required
those
to do it.
called? What what is that
Those
code?
are call districts.
And where did you send us a list of call districts?
I think I don't remember if I put that in the list or not. Let's see.
So if we were Googling, we would do FCC call sign call districts,
Yeah, United States call sign districts.
US call sign districts.
Let's see. U.S. call areas and sections map. Here we go. I'll just put this up on the screen. And you probably can't see it because I'm probably not sharing the right thing. There we go. There we go. So depending on where you are, you can use a self-identified identification. So if I were, like, for instance, I was just in Mississippi, I was signing N7JI/5, which indicates I'm not in 7. I'm now somewhere in the 5 area. Then I went to N7JI/4 because I drove up to Ohio. Then in Ohio, I was N7JI/8 when I was in a hotel, and then drove back down to Georgia and Alabama, and I was N7JI/4 again.
And your email, oh wait, let me just copy that URL. Hold on one second.
I'll just post it.
You'll what?
I'll just put it in the chat.
I'm not sure if it actually copied though.
No, it didn't. Hold on. Copy. There we go. And okay, so those are your call sign areas, call sign districts. So you don't have to do that. However, if you're going to, let's say, the reason, like for instance, I moved from Washington, D.C. area, which is in 3. I had a 3 call, and I moved to Oregon where I was a 7. I said, okay, I'm going to apply for a 7 call because I'm tired of sending NF3I/7. Because everyone would hear NF3I and know where I was and think that I was in Maryland and point their antennas at Maryland when in fact I was not in Maryland. So it just made more sense to, pick a different call sign. Okay, third-party communications. A third party is somebody who is a third party, literally. Let's say that I'm talking to Luetta. We're on the air. I'm the first party, she's the second party. If there's somebody else who walks into the station, typically unlicensed, on either end, they would be a third party. Within any contact between 2 different places that are in the same country, different countries, not including the United States, there are third-party agreements that govern whether or not you can not even necessarily let somebody talk, but even pass any information on their behalf. So they would be third parties. The reason that any country would not permit this is because it doesn't make any sense now, but it's still on the books. Let's say the United States to Japan. We are not allowed to do third-party communications with Japan. Seems silly, right? Everyone's got a phone. Everyone's got a cell phone. Everyone can text each other. But over the air, we are not allowed to do that. The reason being that a long time ago, the Japanese government ran the telephone company. And if they allowed amateur radio operators to pass information on behalf of Japanese citizens who were not amateur radio operators, wouldn't that be taken away from their long distance fees? I think it would. So they said, we're not going to allow third-party communications. Seems a little archaic, but that's the rules, and they're still in play. So within the United States, within the US and Canada, we are still allowed to do third-party communications. If you are curious whether or not it's legal between where you are and some other country, the ARRL has a list of US third-party agreements that are in place on their website. And okay, let's see. When a non-licensed person is allowed to speak to a foreign station, it must, again, have a third-party agreement in place. And finally, if the FCC comes knocking at your door and wants to look at your equipment, and you have an FCC issued license, you have to let them take a look at it. Because this is pretty unusual, but it is possible. I don't know many people it's ever happened to. Usually, if there's if the FCC is knocking at your door, it's because you're doing something like inadvertently, you're inadvertently interfering with local air traffic control. That will get you a visit very quickly.
So they don't need a warrant?
No.
So have your equipment in a Radio Shack.
Yeah, have your equipment in a place where somebody can look at it. I mean, if they're showing
Without
up,
trouncing through your house.
yeah, if they're showing up, there's a reason. I mean, if you're a serial violator of something, then you've been asked to stop and you don't stop, then you could be in some serious trouble. I think more often than not, if there's something that is happening, they might say, you really need to fix this right now. You're interfering with ATC, and that's bad, right? Because that can end up with a lot of people getting really hurt. So
You get a cool handout like when TSA goes through your suitcase and you get that like little card that's like 11 inches long.
I don't know. 40 years, I've never gotten one. So I've never gotten anything. So that's good.
Knock on wood.
Yes.
Save them. I have 11 from TSA.
Oh no, I've gotten dozens from TSA. In
Yes.
fact, every time I fly, they go through my bags. So literally every time I fly anywhere, I just throw them out. I recycle them. Literally dozens and dozens.
I want to see what the FCC gives you. Maybe
No,
a
you don't.
business card.
No, you don't. All right. Well, that's the end of the book. And so it's question time. If does anyone want to talk about the mechanics of taking a test, finding a test, and all that stuff?
We do.
Okay. So I'm going to go and share this right here. I'm going to share this.
So
And
I'm going for my general, but I wanted to refresh some of this, so that's why I'm doing this one.
okay, that's good. That's excellent.
Are you
And,
going to have a general class soon?
I did a general class right around the turn of the year, right around New Year's. And my schedule has been absolutely nuts. I'm the section manager for Oregon, and I have a full-time job, and I travel, and I've got I've got a conference to go to in Seaside, which I recommend everyone go to. And I'm having cataract surgery, and all of those. And field day's coming. Is everyone familiar with field day?
No.
Yes, it's on the 27th and 8th
Or 28th and 29th.
8th and 9th.
So,
And question,
Field day.
is that 24/7? I mean, that's 24 hours that they run it.
Yep.
So like Saturday, Sunday.
It's Saturday at. Well, one thing we didn't cover is universal time. Is everybody good with universal time?
Yeah.
Yes.
Is everybody good with universal time?
Got Google.
No.
Okay, so universal time is defined as the time in Greenwich, England, at the prime meridian.
That's our beginning.
And that's the beginning. And actually, that is the time all over the world.
Zulu time.
Whatever time that is, that's Zulu time.
And then you subtract or add, right?
Yep.
To that.
Yep. And it changes for daylight savings. So right now, Oregon is UTC -7.
Mm-hmm.
So to figure out what time it is,
we're -8 in the winter, right? Or
we're -8 in the wintertime.
Yeah.
So the day starts here at 5 p.m. Except in the winter, it starts at 4 p.m. When I was in Europe, it was UTC +1 because it was Central Europe time, CET.
So they're an hour ahead of.
They're an hour ahead. When I go to Wallis Island, it's UTC +12.
Woo.
Yeah. So the new day starts at noon on Saturday, or the new day starts at noon.
in
because that's
reference to.
because that's midnight in England.
Yeah, my daughter's plus 17, so it takes me a bit to calculate that all the time. And then we get daylight savings, and I hate it.
So let's see. So what
Does AARL have a petition to nullify daylight savings by chance?
No, that's something that has to be done on a state by state basis. Here we go. Find an amateur radio exam. All right, so here's one way to look for one. That's in the link that I sent you. There's also on Ham Study, you can do a search for local and remote exams. There are a lot of exams available. And notice these are all walk-ins, drive-ins, etc. You can also look at remote exams, and there are literally, dozens of exams every day.
There are a lot at 6:30 on Friday night.
Yeah, but I mean, you can take any exam anytime with any group. You're not tied to anyone. So like, let's say you're done and you want to take an exam. So here's one, WM7X, choose 6 a.m. to 2 p.m. You get in contact with them and you pick the time and they show up and do it. So, I mean, this is today. Look at all these different ones that are available online.
Are they timed?
No.
Okay.
Nope. You just sign up and here's one called the Late Night Team. Want to take an exam with the Late Night Team? You can sign up with the Late Night Team. I know somebody who gave an exam to somebody who was in the Middle East, and they were many hours ahead and on the roof of a building. You have to be someplace that is secure and has to be able to be certified as you're not cheating. But beyond that, now the other thing is that for practice
You can do
exams,
remote exams too, right? Sorry to interrupt, but yeah.
Yeah. Well, that's for remote exams.
Okay.
You're responsible for your a lot of people end up going to the bathroom and then locking the door. That because you're not allowed to have people walk in and out.
I see.
So practice tests. So you can take practice tests, continuous cast. I still like the online ham radio exam book. But yeah, you can electrical resistance, that would be ohms.
So I assume these are all closed book.
Yes. But I mean they're closed book, but all the questions are published along with all the answers.
Right, but I'm saying if I have a handy chart that somebody gave me as part of the class.
No.
And I wanted to put that on my desktop and have that to refer to.
Yeah, they'll stop that exam immediately.
Oh, okay.
And what about a calculator?
It has to be a dumb calculator.
So no storage functions, but log.
Yeah,
or,
I mean,
exponents.
Like you can have memory plus and stuff like that, but it can't be programmable.
Like text, you can't have a T1.
Right. It can't be programmable. Like you can't run a program that says calculate this antenna length.
When you said that you prefer the online book, Ham Radio, you're talking about the one that hamradio.org has?
Yeah, let's see if I can find it, if there's a mention of it. Here we go. And I know this is it's a phone-based app, but this ham radio exam technician. And I mean, I don't know what happens when I go to Google Play, but yeah, that's what the icon looks like. And that exists for the iPhone. And what's cool is that you can study section by section and drill on individual sections. And they're only about 10 questions long. The whole question pool is about 450 questions. This breaks it up and allows you to drill on every section and then wait and, basically go through it and finish that section after you're getting 100% and then move on. Instead of having to see them all. So
do you recommend that over the hamstudy.org
I do.
app?
I do for that reason.
Okay.
I think it's if you study, if you practice one section at a time, it makes it a lot more digestible.
And you said there's roughly 450 questions?
Yep.
Okay.
I mean, you can do what my wife did, memorize every single one. She's
So
good at
when
that.
it has you calculate antenna length, it's the same variables every time?
It will be the exact same question that you have already seen.
Wow.
Well, I mean, that's I've seen 6 and 7-year-olds pass. They certainly don't know all the algebra, but they can remember stuff. So really, it doesn't. It does. It's kind of a dichotomy here. You don't need to know anything to pass this exam. You really don't. You need to be able to study. You need to be able to remember things. Now, it helps if you know the theory behind it, because if you forget something, you can always go back to it. And it certainly ends up with you learning more. But I will be honest, when I was 17, I said, I got to get through this. I'm giving myself 1 month to pass every exam. I had started at I had to pass Tech, General, Advanced, and Extra. And every month I bought a new book and I studied the heck out of the book while I was in college, my first semester of college. And I went in and I crushed that exam and I bombed the next one because I'd studied for it. I didn't know all the math behind it, but I knew how to take a test. So what I hope to do for everybody here by doing classes like this is to make it make more sense and to give it, because it's like if you're in math class, and I wish my math class had something practical. All the way through college, I wish my math classes had been practical, but they weren't, right? They just said, here's what to do and here's how to do it, and go learn it.
I hear if you take business math, they actually have practical.
Well, I mean, but you know what? It wasn't until I was out in the real world that there were actually like real problems that I could solve using calculus. I'm like, well, this is cool now, right? I just have to set up this equation and I have to do an integral, and oh my God, I can do an integral. Oh my God, I can figure out how to do this. But, that was like, years after I learned it in college.
It makes a difference when there's a paycheck behind it.
Well, and there's a reason to be doing it.
Right.
There's a tangible reason. Like I gotta figure out what the flow rate of this tank, what the fill rate of this tank is. And it's a cone at the bottom and a cylinder above it.
So hey, what about what do you think about signing up for the technical and attempting the general in one sitting?
Do it.
Yeah.
Yeah.
Doesn't cost you anymore, right?
Nope. And if somebody who, let's say somebody is prepared for the technician class and they've never looked at the general before, in my experience, they'll still get 50 to 60% of everything right on the general.
Thank you, Scott, for this class. I'm going to head out.
All right. Thank you.
Scott?
And I'll stick around to answer more questions.
Can you hear me, Scott?
Yep.
Do you
Hi,
teach
Jim.
old guys
Do I teach old guys what?
anything? Old guys.
Well, you're not that old. Are you? I doubt you're even the oldest one in this room, Jim.
I'll be 82 in July.
Does anybody have Jim beat?
No.
What?
I do.
Do you? How old?
I am 82.
There you go, Jim. Sorry, Jim.
It's all right. Thank
Man,
you for
Scott, you
smiling.
just made it. You made it under the wire on that one, dude.
I had a neighbor that's driving Corvettes and a Mustang and a sports car, and he's 84. He's got
Wow.
like two girls chasing after him. Two
What
young
is Jim's handle who was just talking a second ago? Because I'm not seeing a Jim among us.
No, it's WB7TAZ.
Hello.
I have a question for you.
Yep.
Good luck.
If I sent you a list of my equipment, I'm just getting it ready to hook it all up. Could you kind of just, say this goes to this goes to that to make sure I don't make any mistakes, stupid beginner mistakes?
Well, what mistakes would you make?
It's sad, but I'm not smart enough to know what they could be, which lets me know that I don't know.
Well, you learn a lot, but you learn more by making mistakes than doing everything right.
I'd rather not blow out my
Oh,
radio.
you won't blow anything up. What if you're hooking up a power supply? You know the difference between red and black?
Yes, I
Okay,
do.
oh, that's a good start. That's the first step. And if it's a if what I mean, is it a like a dual band radio, dual band mobile, FM?
No, it's a base station. It's uh an older one. I'm trying to think of the name. I always do this because I have another one that's being repaired. I had to send it all the way to Georgia to have it repaired.
Okay.
Because it was the only place that does the radios. Like, 'cause this is an older one. It's an older ham radio. Trying to think of the brand. I'll have to send you the info.
How old is it? How old are we talking?
Probably 10 years old,
Oh,
older
that's
than
not
that.
old. That's not
10
old.
to 15.
That's not old at all.
Well, the person upgraded and who gave it to me and said it's old. So
Well, Yaesu, ICOM, Kenwood, Tentec, Swan,
it's
Collins.
a Kenwood. It's a Kenwood.
Okay. So 520, 120, 130, 140,
Let me go
570.
grab the book for it
Yeah,
really quick. Let me
570,
go grab the book.
590. While she's doing that, any other questions?
So Scott, you contact these facilities, you pay them $15
Or whatever
and
they
they
charge.
take the test or whatever their fee is. I saw it was 15. And then do you pay them the $35?
Nope. The mechanics are that you take the test, you pay them, that covers their expenses. They are part of and governed by a volunteer examiner coordinator that's a part of the NCVEC, which is the commit or the National Committee of Volunteer Examiner Coordinators. They work with the FCC to design all the questions and stuff. Once they run your information into the FCC computer, the FCC computer will take a look at all the information and spit out an email to you that says your license is ready. Please pay the $35 fee. And then you'll have to pay the FCC through the CORS system. So it's definitely a little more streamlined than it was originally, but it'd be nice if it was all in one chunk, but it's not. Is there anyone under 18 here still? Thought we had one. Jim, you're not under 18. Don't even try.
This is backwards. His is transposed.
Yeah.
Oh, I like
Because
that.
if you're under 18, ARRL testing groups will charge you $5 for an exam, and then when they submit it to the FCC, you can apply for a grant to cover the $35. So when does everybody have exams scheduled?
June
Tonight.
27th.
Did someone say tonight?
Yeah.
Cool. Okay, so I heard the 27th. Is there anyone who hasn't scheduled an exam yet?
I have
not.
I have not.
Okay.
I was going to wait to do this study test for general to see how I do.
Okay, but here's what I have to say. All right, I'm going to put it in the chat. I have seen that happen so many times. Or like, you went through the whole process. You spent an entire freaking weekend with me and you never took your test. Why? Why? Well, I just never got around to it. And the further you get away from the process of having gone through this, the more you're going to forget and the less the chance you're going to go back to it.
2014.
Yeah. Well,
that was me.
2014.
Yeah.
When
So Scott,
yeah.
go ahead. You said that if you just went ahead and took the general test, there's like a 50 to 60%, correct?
Yep.
So how much studying do you need to know of general, do you
You'll be
think,
done-
to pass?
If you go through that same app, you'll be done in a week.
Okay.
I mean,
What?
there's
Say that again? You what?
what? If you're if you're crushing the technician exam and you spend an extra week really working on the general class stuff, you'll do fine on the general also. Because there's a lot of overlap. What you end up working with is the fact that when I go and share this right here, and I go here, you will note that the band plan for the technician exam covers all of this stuff up top, right? All the VHF and UHF stuff. When you do the general exam, you now have access to all these high frequency bands. That is the major change. Every one of those bands, you have different frequencies, you have different power levels available to you, you have different privileges. So that constitutes a lot of the changes because by and large, the FCC rules that govern amateur radio are the same rules that govern amateur radio, right? Whether you have a technician or a general or an extra class license. So essentially the difference is that you may have some of those rules covered again, which you already know the answers to, plus all these new bands that you have to learn. And there's a little bit on vacuum tubes and a little more electronics, a little more in depth, but it's an incremental change. It's not a huge difference. So, my recommendation is get online and schedule an exam. Give yourself a line in the sand that you're going to meet, because otherwise, like I don't do well with ambiguity. If I don't schedule something, things have a way of slipping. So just make a schedule for an exam and go do it.
I'm back.
Yep. All right. So what is it?
It's a Kenwood TS 44 440S.
Okay, well, that
Nice.
is not 10 years old. I can
That's
tell
the
you that's
late
from
70s.
mid to late 80s.
Oh, okay.
And one thing I can warn you about, I hope it's not too expensive to fix. Because he said it was being fixed.
No, I had to send it to Georgia to have it
Right.
repaired,
Right.
and it's back now.
Okay, I hope it didn't cost too much to repair.
Why?
So, why? Well, okay, so that particular radio, I can tell you it was a good radio, but they had a propensity to have problems with their voltage control, with their VCO locking, which is essentially it's a synthesized radio, so it synthesized its oscillators instead of being like tunable with capacitors and stuff, and they could have issues with some of the glue on the boards and some issues with capacitors. And if you ended up with if you turned it on and you ended up with a bunch of dots on the screen instead of a frequency, that would mean that the VCO unlocked. If it's not doing that, you'll be fine.
No, it had a different problem. and I had to ship it there and they shipped it back and I haven't taken it out of the box because I just got the desk put up and everything. So
Yeah. So yeah, it's a decent radio. It's got an internal power supply. And yeah, you'll get some good use out of it.
Hey, real quick
you
question.
said it
on-
has an internal
No,
power
sorry, it has an
supply?
internal antenna tuner, external power supply.
Yes.
Somebody else was asking the question.
on the test, for example, out of 11 tests, I passed 6 times. I failed 5. 3 of them were 80. One was 82. One was 85, and one was 90. Do I still need to practice more?
Yes.
Okay.
When was that? Before, or was that today? Or
They're fairly recent. So the oldest one was earlier this, like the 12th.
You can try it, but the problem is that, I after doing this for a long time, people will make more mistakes on a live exam than during a practice exam.
Yeah.
Just because of nerves. So you got to get 30, you got to get 26 out of 35. And if you're averaging 28, that means, that's why I say you really got to be a solid 85%.
Right.
If you want to be comfortable.
Do you get your results like immediately, like after a practice exam, and can you immediately retake the exam?
Yep.
Okay.
How many questions are on the exam?
35.
That's not bad.
And you said there's a 450 question.
Roughly 450 questions. Yeah.
It's not 350, it's 450.
All right.